Is it visible, sir? Is it visible, sir? Am I audible at all?
Yes, sir.
Okay, okay, sir. So yes, the today topic is fuel characteristics. We are going to cover some few important fuel characteristics and how to determine the fuel characteristics for biofuels. So there is a thing, yeah, we all of you know that there is a need for alternative power sources. Yes, there is over dependency on petrol and diesels, but it is keep on depleting. Yes, keep on depleting. Again, this rising petrol and diesel prices. So we cannot have the control over this rising petrol and diesel prices. Again, one more interesting fact: there is a pollution and that result into global warming. Yes, noise in conventional vehicles. Stringent emission norms adopted for all over the countries, not only in India. That is, we go for all the developed countries. We are having some stringent emission norms. So these are the things. These may force us or motivate us to search for alternative fuels. Okay. So here there are some possible alternatives such as biodiesel, ethanol or alcohol-based fuels, ethanol, methanol, and biogases to meet our energy requirements. Among these, yes, the biodiesel, ethanol, methanol, yes, ethanol, methanol, and biogas can produce either from vegetable oil or food waste. The extraction of, yes, here, this is an interesting point, the extraction of natural gas and the production of hydrogen requires expensive methods. Again, this if we go for, yes, we can go for electric vehicle. Instead of going this type of things, we can go for electric vehicles. But again, we are indirectly dependent upon the conventional fuel like, yes, coal and petroleum products. Okay. So this slide shows the fuel requirements of engine. Yes, there is a, if it's a petrol engine, we can add 5% to 10% of ethanol to the petrol with or without engine modification. Okay, it's okay for petrol engine. But in the case of diesel engine, because the most of the heavy vehicles are made up of diesel engines. So in case of diesel engine, we can go for different fuel modification techniques in order to meet the better combustion, performance, and emission characteristics. So here we are having some ideas. So we can directly add some some vegetable oils. The vegetable oil may be in terms of edible oil or non-edible oils. So some examples of edible oil is sunflower oil, soybean oil, corn oil, and waste cooking oil. Then non-edible oil is cottonseed oil, rapeseed oil, or opium poppy oil. Some examples. So using straight vegetable oil will lead to, again, before going for this biodiesel, we can use some percentage of vegetable oil, or directly we can use 100% vegetable oil into the C engine or a combustion ignition engine. So if we use this type of straight vegetable oil, it will lead to some fuel injection problem. So it may affect the injection characteristics because of it can cause some higher viscosity. So the biodiesel will be only one option for diesel engine. So the biodiesel, we know that, just I am repeating the same words, the biodiesel is referred as a monoalkyl ester of long chain fatty acid derived from renewable sources. Then the biodiesel can be obtained from different type of vegetable oil or even animal fats we can obtain. Then it's the important attributes or important characteristics of biodiesel is, yes, biodegradable, non-toxic, and possesses low emission profile. Yes, it's environmental friendly fuels. Okay, nice. So why we are going for the biodiesel? Again, the same things are repeating. So crude oil prices and fossil fuel and environmental concerns. So we need to focus on one new type of biodiesel. So yes, when you go for the new type of biodiesel, the interesting point is we go to check the fuel characteristics. Yes. So there are some techniques in preparing fuels. Yes, we can simply blending. Blending the vegetable oil can be blended with biodiesel, or maybe it's even the biodiesel. Some percentage of biodiesel can be blended with diesel fuel, blending or micro emulsification. So here this main purpose of this method is to use to reduce the viscosity of the oil. Even though if you are having the biodiesel viscosity may be somewhat higher than the diesel fuel. So we need to reduce the viscosity. Once we are having great control over the viscosity, we can control the fuel spray pattern. Once fuel spray pattern is very good for our engine, means we can get a better combustion and better emission levels. At the same time, obviously we can get the performance. Okay, so the blending and micro emulsification, cracking and transesterification. So the blending, yes, vegetable oil can be directly mixed with the fuel. Even you know that the 1982, 95% of filtered used cooking oil and 5% diesel added. And they found that from their observation, they found that the blend of 20% of oil and 80% of oil was found to be successful. So that's why nowadays everybody move towards B20. That is 20% of biodiesel and 80% of vegetable oil. So the biodiesel may be produced from any kind of feedstocks. We are not bothered about it, but the 20% and the 80% will give the very good combination. Yes, even if we can go for 100% vegetable oil, but we need to go for some minor modification in the fuel supply system in diesel engine. Yes. So in the fuel cost, major problem is the fuel is cost. We discussed. So the microemulsification. So this is one more method to use vegetable oil. So microemulsification. So we need to add vegetable oil with some alcohol-based fuels. So methanol, ethanol, and butanol, we can use it. Okay. When we add for adding methanol, ethanol, butanol, and vegetable oil, we need to go for some surfactants. So the surfactant may be some different chemicals. It has some mice-like different type of mice-like arrangement. So one end is catches the oil vegetable oil molecule, and one end catches the ethanol or alcohol-based molecule. So the emission had the emulsification had a viscosity of 6.3 centistokes normally. So in the lower viscosity, so when you go for the microemulsification, we can improve the viscosity. That means we are reducing the viscosity of the vegetable oil. Then cracking, the one more method to use vegetable oil in the C engine. Yes, in the presence of with or without aid of catalyst, but the options of air. So in the vegetable oil is ordered with some we are going to preheat it at the same time, and the preheating takes place. Options of air are oxygen. So in the chemical bonds to yield some small molecules. The chemical bonds of the vegetable oil means breaks, and it needs some small molecule. That is known as a cracking. That also one more method to produce one more way to use vegetable oil in our C engine. Okay, this is the third method. Then fourth method, yes, the fourth method, most of the people are keep on discussing about yes, transesterification. We know that the first thing, the biodiesel, it's a vegetable oil itself is ester. Vegetable oil is simply ester. So we are converting one ester to another ester. That is transesterification. So it is a reaction of fat or oil with an alcohol to form a esters and glycerin. Yes, I saw the very good diagram. So the catalyst is used to improve the definitely we need catalyst to improve the chemical reaction between oil and alcohol. Or the oil, I'm saying the oil means the vegetable oil. So among the alcohols, yes, the most of the different type of alcohols, the methanol and ethanol is used as a commercially used due to their low cost and physical and chemical advantages compared to other alcohols. When you go for butanol, when you go for dimethyl ether, if you use this type of things, then it will not do the proper yield. That means proper biodiesel conversion. So the mixture of vegetable oil, yeah, here this is a mixture of vegetable oil and sodium hydroxide are heated and maintained normal. So the vegetable oil and sodium hydroxide, this is a generation 1 biodiesel. So the vegetable oil and sodium hydroxide heated and maintained at 65 degrees centigrade for 1 hour, we can get the biodiesel. 1 hour or 2 hours, and we need to mix we need to go for continuous stirring. Okay, then we can get some biodiesel. This one that means in the generation 1 biodiesel concepts. Yes, here this slide gives us a clear picture about transesterification reaction. Here you can find triglyceride. Yes, this is a triglyceride in which R1, R2, R3 are fatty acid alkyl groups. Fatty acid alkyl groups. Amount of fatty acid, yes, the fatty acid, because this whole thing is considered the triglyceride. That means it's a vegetable oil. It's a vegetable oil. It consists of some fatty acid alkyl groups. So the fatty acid alkyl group is mainly a function of some flow properties. Particularly, it's called as a cold flow property. Anyway, the later we are going to discuss about what is cold flow property something. So the flow properties like CTA number and cloud point, pore point, etc. Here you can see this, the triglycerides mixes with 3% of 3 times of methanol or alcohol. It will give the biodiesel and the glycerin. So the glycerin is a byproduct. This is we already know that it's a transesterification process. So for example, the fatty acid here, this is a fatty acid. Some free fatty acid are also present. Free fatty acid is present in the vegetable oil. So before selecting the transesterification process, we need to check the free fatty acid present in the vegetable oil. So the free fatty acid is we can calculate in terms of acid number. Once you find the free fatty acid, then we can go for the steps involved in the transesterification. For example, the free fatty acid is more than 2, more than 1 means we can go for 2-step transesterification process or 3-step transesterification process, alkaline transesterification and acidic transesterification. Some different type of concepts are there. Yes, this slide puts the information about the sunflower oil based biodiesel bulks with the different blending ratios. Here you can see this for our understanding blending ratios as per customer engine modifications for our understanding. Then yes, the same thing. One more slide. It represent the biodiesel chemical reaction in the simplest way. Yes, yes, it is free fatty acid and glycerin or glycerol. Both of them, glycerin, glycerol, all are same here. Yes, there is the fatty acid and glycerin or glycerol can be considered as a vegetable oil. When the vegetable oil from any feedstock, an alcohol with the presence of catalyst, and when you go for the enough heating and stirring, then we can it will yield biodiesel and some byproduct like glycerin. The glycerin we can find some trace of alcohol and catalyst. In the glycerin we can find some trace of alcohol and the catalyst. Okay, this is the thing. Then the remaining things are same as like what we discussed. So there's a general attributes of biodiesel. It's a lower emission. It has high flash point, so it's safer to handle and safer to store. Then biodegradable and essentially non-toxic. Okay, so the biodiesel can produce from any kind of vegetable oil or animal fat, but the yield comes out from the vegetable oil depend upon the free fatty acid or fatty acid present in the vegetable oil. That is really important. That's why the most of the vegetable oil will not yield the required percentage of biodiesel. Yes, the same thing repeating. The renewable alternative fuel produced from wide range of vegetable oil and animal fats. So biodiesel is made up of fatty acid alkyl ester and maybe methyl ester or long chain monoalkyl ester. All are same. So some positive performance attributes is in the CTI number. So the CTI number is very much important for it represents the ignition quality of the fuel. So if it's diesel engine, we need to take care of the CTI number. If it's a petrol engine, we can go for octane number or octane rating. So the high fuel lubricity and high oxygen content, I will show the biodiesel molecule, then you can get some ideas. High oxygen content, which may make preferred blending stock with future ultra clean diesels. Even that is the biodiesel can be produced from different feedstocks such as canola oil and olive oil, yes, the castor oil, the soybean oil, and the palm oil, even waste frying oil, cooking oil. We can produce a biodiesel, yes. In addition to that, we can produce a biodiesel from polluted waste, yes, that's right, it's polluted waste and animal fats, even chicken livers we can produce. But common biodiesel attributes are same. So this slide, one more interesting point about the biodiesel. Yes, here please, all of you please concentrate here in this point. So it is a carbon neutral fuel. Yes, you know from this diagram we can find the biodiesel obtained from any kind of feedstock can be fueled in automotive to meet our energy requirements. The major emission constitution like carbon dioxide, which may come from the tailpipe of an engine, then the carbon dioxide is slowly absorbed by the crop or plantations. So the cycle is the carbon neutral fuel, biodiesel carbon neutral fuels. Yes, now we are come to this one very interesting fact here. The biodiesel contains no sulfur or aromatics. So, but in the diesel, we are having some percentage of sulfurs in terms of 15 ppm or 500 ppm or 300 ppm, some different percentage or different kind of sulfurs are available in diesel. But one more interesting point: the major difference between diesel and the kerosene is only sulfur content. So the sulfur content in the kerosene is more than 500 ppm. Let's say we cannot use kerosene as a fuel for diesel engines. But in the case of diesel, we are reducing the sulfur. Then maybe the amount of the sulfur may be less than 15 ppm or 10 ppm. Which is a grade 1 diesel. So here the thing is, the slide gives some detailed information about the biodiesel molecule. Yes, it consists of we see this, please see this. These oxygen molecules. Here, this red thing is oxygen molecules and carbon molecules and hydrogen and hydrocarbon chain. This is a methyl biodiesel molecule. We know that. So, due to the presence of what is significant? So, the presence of this oxygen will lead to better combustion. At the same time, we can get lower emission profile. But again, this big trouble is the oxygen present inside the system means automatically it will increase the NOx emission. But few literature reported the biodiesel produce lower NOx emission. That means due to some iodine number or some other different type of factors available in the fatty acid methyl esters. Okay. Yes. The next one is the biodiesel usage in engines. Yes, the biodiesel has higher flash point. It's more than 150 degrees centigrade when compared to 52 or 53 degrees centigrade for petroleum diesel. Biodiesel is safer to handle and store. Yes. So before going for this fuel characterization, we need to know American standard for testing materials. It is ASTM specification D6751. ASTM standard D6751 will be considered as a specification or standard for biodiesel fuel characterization. Yes, the renewable diesel fuel. Sometimes the biodiesel may be considered called as a, or maybe considered as the renewable diesel fuel. Yes, diesel fuel mostly closely associated to production from the hydrotreating of renewable feedstocks, or such as fats and oils. So yes, here's the basic thing. Then the fatty acid methyl esters and the monoalkyl esters of long chain fatty acids. Fatty acid methyl, what is the meaning of FAM? It's nothing but monoalkyl esters of long chain fatty acids from naturally occurring in the plants oil, animal foods, and recycled greases. Yes, what is fatty acid? In this fatty acid methyl esters, nothing but biodiesel. Simply we can call it as a biodiesel, as a FAM, fatty acid methyl esters. So we are using methanol as alcohol to produce a biodiesel, it becomes methyl ester. When we use ethanol as alcohol to produce a biodiesel, it becomes a fatty acid ethyl ester. That's all. The renewable diesel fuel is nothing but against biodiesel. So what is fatty acids? The fatty acid is different type. There's any kind of saturated or unsaturated monocarboxyl acids that is naturally occur in the form of triglycerides, maybe mono or triglyceride or free fatty acids in the fats and fatty acids. So when we select the fuel, when we select the vegetable oil, for example, if we take a palm oil, or if we take a canola oil or a soybean oil, first we need to check the free fatty acids. How much amount of free fatty acid is present inside the particular vegetable oil. Then based on the free fatty acid, we have to take care of the transesterification process. Yes, here this slide shows some sequential steps for the production of biodiesel from waste cooking palm oil. I did these steps in my research work. First of all, we need to know the quantity of catalyst. The first thing, yes, we know the biodiesel reaction. So vegetable oil is there, then alcohol is there, then catalyst is there, then the vegetable oil and alcohol is the reactant. Catalyst maybe is a potassium hydroxide or maybe sodium hydroxide. Then it will lead biodiesel and some byproducts like glycerin. But before that, we need to check the quantity of KOH and quantity of vegetable oil and quantity of alcohol. So for that, we need to do some preliminary steps to find and which amount of vegetable oil, which amount of say alcohol and the catalyst produce a maximum yield that we have to find. So the first step, we need to quantify the catalyst, waste cooking palm oil and alcohol. So the waste cooking palm oil I collected from some restaurant nearby Trichy, and I preheated the vegetable oil. Let me show the diagram. In the KOH, then formation of lye. That means I have selected. This is my research work. That's why I'm telling. So this I am prepared. I have taken methanol. Methanol is the alcohol for my research. So and the methanol is ordered with the potassium hydroxide. Then that we consider as a lye. This is formation of lye. The combination of methanol and KOH formation of lye. And next one. So we need to preheat the waste cooking oil. Yes, the cooking oil is that we keep on frying some the vegetable food material, or maybe it's a meat or some other thing, but we need to preheat it. So we need to preheat it in order to remove the moisture from the waste cooking oil. So preheat. Yes, next is the transesterification. So in during my research, we had one very good transesterification setup at NIT Trichy. So here this is a round bottom flask in which I am pouring vegetable oil. That means the preheated waste cooking oil and this lye, and the round bottom flask is keep on maintaining the temperature 65 degrees centigrade, and then this solution is keep on stirring. This some constant speed of 200 RPM or 300 RPM something. And this is a transesterification process for 1 hour or 2 hours. You can get the products. The product maybe it's a combination of biodiesel and glycerin. That is based on a chemical reaction. We know that biodiesel and glycerin. So we need to separate with the help of separating product. This is a separating product, particularly gravity separation methods. The next is distillation. So even though the produce, after 1 hour or 2 hours, the top layer may be considered the biodiesel, bottom layer may be considered glycerin because they are having the two separations. The top layer is a low density biodiesel and the bottom high density glycerin may be present inside the separating funnel. So the top layer may be taken carefully and again it's heated to remove the excess methanol present in the biodiesel. Otherwise, the methanol leaves methanol is some peculiar effect on rubber material present in the engine. So we need to remove the methanols. So distillation to remove the methanol. So for distillation purpose, we are having some condenser arrangements. Then is heating. So once after removing the excess methanol, we need to again heat the biodiesel up to 120 degrees to break the glycerate chain. If there is excess glycerin, because we are taking the top layer from the separating funnel, so we need to heat it to remove the or to break the glycerate chains. Hence, immediately it's cooled to say it's atmospheric temperature. It's atmospheric temperature is okay. And cool to the atmospheric temperature, automatically the glycerine maybe comes out. They can remove the glycerate from the biodiesel. So the separation of glycerine from the biodiesel. In some cases, yes, in some cases, the scientists or the research people they are using water. That is they are using water as a cleaning agent for this biodiesel. So the water washing. Next slide, this slide, yes. After water washing, biodiesel, yes. You see this here, you see there's a processor. The washed biodiesel will pour the water, then washed water, there is a processor, then the water will be removed. Then the biodiesel will be stored in the tight container, air-free container. Then the biodiesel are allowed to dry, then the biodiesel will be transferred to the automatic fuel tanks. Okay. So I hope these slides may give you a clear picture about the production of biodiesel. So some cases we can go for water washing, and some cases we can keep on preheating it, or we can keep heating up to 120 degrees centigrade, and then we can suddenly cool, and we can remove the excess glycerine. But even though some percentage of glycerine is present inside the biodiesel, means it will affect our fuel characteristics. That's why we can go for water washing. So yes, that's all about the biodiesel production and the transesterification process. Yes, even though we are having the different methods to produce the biodiesel, we need to overcome some barriers or challenges like this. Yes, the transesterification is use of vegetable oil and animal fats as feedstocks. It's interesting here is the expensive feedstocks. So even if you get a 1 kg of sunflower seeds, the cost is more. 1 kg of say it's a 1 kg of palm oil, it's also the cost is more. Expensive feedstocks and inefficient production method. So some cases because we are not having proper quantity of oil or alcohol and catalyst means, then we cannot get the proper yield, proper biodiesel yield. This inefficient production methods. Then reaction of fat or oil with an alcohol to form a ester. So the reaction should be perfect. The strict standards for production quality. And again, big trouble is even the biodiesels are major culprit for NOx emission. Yes, we cannot deny it. NOx emission, the major culprit for NOx emission. So again, the biodiesel produced should be stored above the cloud point. For example, if I produce a biodiesel, I am keeping the biodiesel at the atmospheric temperature. You say it is 27 or 26 degrees Celsius. Say. But if I keep the same, I am using the biodiesel, I am driving my car towards Siachen. What will happen? The temperature may be 5 to 10 degree, or we say it's less than 10 degree, or sometimes that the biodiesel may create some wax or precipitation inside the fuel molecules. It may affect our quality fuel characteristics. That are all things that we are going to cover. Yes, the next one is the in this slide we can get the knowledge on some few challenges. Yes, again the same thing repeats. The increasing yields on oilseed production, multi-feedstock biodiesel. Even nowadays, the people are mixing different type of biodiesel. Say it's a 30% of palm oil and 40% of canola oil, and say 30% of sunflower oil. They are mixing all those things. It may affect. Yes, we can get a better fuel characteristics, but it may not give the proper performance. Okay, that is we need to check. Then establishing the quality standards of different materials. That also very interestingly. Then development of analytical methods for quality control for processing product that we are going to cover. Yes, one more point that is. So for mass production, so far we discussed only there is a batch-based production of biodiesel. For mass production, we need to go for biodiesel reactors. So the biodiesel reactor means we can control the operating pressure of the vegetable oils. So some vegetable oil may have a higher vapor pressure. We cannot control it. So we need to go for this type of biodiesel reactors. So the biodiesel reactor consists of pre-reaction equipment. It includes oil storage tank and alcohol storage tank and a catalyst storage tank. From that, everything passes to the biodiesel reactor in correct quantity or prescribed quantity. Then the reaction takes place. Apart from that, we are having some pumps and filters and plumbings. Yes, this slide gives some idea about various biodiesel chemical products. Here you see this. For this one thing is for represent your biodiesel reactors. Here, the crude sunflower oil may contribute to sunflower biodiesel, crude frying oil will contribute to biodiesel. Here, from this visual inspection itself, we can understand the viscosity may be decreasing. Then here, these are some failure pictures. Here, you see this. Some cases, for example, one trial, I am using some quantity of, say it's 100 ml of vegetable oil. I am using 5 milligrams of KOH and 20 ml of, say 20 ml of alcohol. It may lead to some glycerin formation. So in some cases, we cannot separate biodiesel and glycerin. This has some big trouble. In some cases, if it is over preheating, the color of the biodiesel get modified. That means again some keep on frying the oil. What will happen? If you keep on frying the oil, then hydroperoxide will form inside the biodiesel. It will decrease in the oxidation stability of the biodiesel. These are some factors involved in biodiesel. So yes, the post-reaction equipment. The post-reaction equipment, yes, the settling tank and separating equipment and washing equipment, and drying equipment, and biodiesel storage and glycerin storage, and some pump and filter are for this for biodiesel reactors. This is only for biodiesel reactors. Here, yes, the crude glycerin. Here, the one more points say the byproduct of biodiesel is a glycerin. There is no ready market for the glycerin. The quantity maybe it's a 10 to 20% of biodiesel production. We cannot modify it because the purely is chemical reaction. So the glycerin comes from the fatty acid methyl ester. There is a vegetable oil, so we cannot remove it. Then it contains some methanol catalyst in some cases. Yes, if you are not properly purified, it contains some methanol catalyst. The possible may be considered some fertilizers or composites or fuel oil and some pharmaceutical grade glycerins. So usage of glycerins. Some cosmetic items also we can develop with the help of this ethanol. Listen, even the soap, some cosmetic soaps we can do. Yes. So this slide shows the biodiesel usages in engines. Yes, here as per the US Department of Energy Studies, use of biodiesel resulted 78.5% reduction in carbon dioxide emission. Yes. Again, one interesting fact: the cold weather storage requires additional step to keep the biodiesel usables. For cold weather conditions, say it's 5 degrees, say it's minus 5 degree, minus 10 degree, we cannot use biodiesel. At the time, we need to go for some different type of additives to control to maintain the quality of biodiesel. So again, it contains general observation of the biodiesel 8% less energy per gallon than petrol diesels. Okay, but B20, yes, B20 is 1 to 2% difference in fuel economy. Even though if we are using B20, no need to modify the engines. But it will not affect the fuel economy. 1 to 2% difference only it will provide. Then B20 users reports no noticeable difference in performance or fuel economy. Even the government of India and other developed countries, they are trying to use 20% of biodiesel in diesel, but it will not give a notable or significant improvement. That's the thing. Yes, this is biodiesel attributes. Yes, these graphs represent the percentage change in emission on y-axis in percentage biodiesel. The percentage biodiesel, the biodiesel may be what biodiesel features may be different, but this is general observation. So when the biodiesel blends keep on increases, this is nothing but 100 is like 100% biodiesel. 80 means it's a 80% biodiesel or 20% diesel. So there is a total hydrocarbon emission get decreases, then carbon monoxide get decreases, and particulate matter get decreases. But when we talk about this B20 alone, there is no change in NOx emission, and again the particulate matter emissions decreased by 10%, and the carbon monoxide emission by 11%, and hydrocarbon emission by 21%. This is a B20 impact. Yes, now we are come to our concept, this fuel characteristics. So diesel engines are, you know that diesel cars are more expensive on those. So diesel engines are expensive. So we need to consult the vehicle manufacturers or engine warranty statement before using the biodiesel and use of biodiesel blends. Whether this biodiesel or biodiesel blend meets the ASTM quality standard or not. We need to check. So further, the commercialization of biodiesel, yes, the commercialization of biodiesel will boost the economy of urban and rural areas. You know what? So there is a next one. Before commercialization, we need to know the four grades of biodiesel. This is a very interesting topic. The four grades of biodiesel are used as a blend component with middle distillate fuel. Middle distillate fuel is nothing but a diesel. That's all. So we are having four grades. Grade 1 BS15, grade 1 BS500, grade 2 BS15, and grade 2 BS500. So grade 1 fuel is a special purpose biodiesel blend stock, which can be blended with Middle East diesel fuel. That means Middle distillate fuel or diesel fuel. This type of biodiesel blends are sensitive to partial presence of glyceride. That's why we need to remove the glyceride from the biodiesel. Partial percentage, even the partial percentage of glyceride, it will affect the fuel characteristics. Partial reacted glycerine. At the same time, this type of biodiesel blend stock should have some good low temperature operability, and also it's like a fuel blend component to 15 ppm sulfur. So we need to add the diesel with less than 15 ppm sulfur content. Beyond that, we cannot use. We cannot add the diesel into the biodiesel. This is the concept of biodiesel blend. Even if you take the biodiesel as 80%, but the sulfur content of the diesel is 15 ppm. Beyond that, we cannot consider special purpose biodiesel blend. Similarly, one more category for grade 1 BS500. This is also sensitive to the reacted glycerine or glycerides, good low temperature operability, and a fuel blend compound with 500 ppm sulfur. So here we can add the diesel with a sulfur content of 500 ppm. It's no problem. This is grade 1 BS500. But general purpose biodiesel blend stock, BS is nothing but blend stock. Blend stock are using with the fuel component with 15 ppm sulfur maximum. Then biodiesel blend grade number 2 biodiesel blend stock 500 means the fuel component with 500 ppm sulfur is allowable. These are four grades of biodiesel available in the market. Yes. This is a distillation. Yes, very nice. Distillation. Distillation shows the grade wise. Yes, the grade wise biodiesel along with the various fuel properties. The first column represents the fuel properties, possible fuel properties, and the second column represents the reference ASTM methods and these four grades of biodiesel blends, biodiesel stock blend, BS15, grade 1 BS500, grade 2 BS15, and grade number 2 BS500. Yes, the sulfur. We need to calculate the sulfur for the reference method D5453 and cold stroke filterability in terms of seconds. So for example, the temperatures keep on decreasing. At the same time, they are passing the biodiesel into some filter paper. Then they will find how much seconds it will take to pass through this filter. So the maximum limit is 200 seconds. Then it will pass these conditions. Similarly, the sulfur present in this grade 1 biodiesel is 15. That means 15 ppm is 0.0015. Grade 2 means 0.05. Sorry, grade 1 BS500 means. Then grade 2 means the same values. Then monoglyceride, the amount of glycerides present in the biodiesel, 0.4. Yes. The calcium and magnesium. So some high traceable metals present. So the metals maybe comes up from the catalysts. The catalyst may create some site reaction inside the biodiesel chemical reactions. It may create some site reaction. So the calcium magnesium may be produced. That amount should be less than 5 ppm for all category. Yes, the flash point. So we need to go for closed cup, particularly automated closed cup Pinsky Martin flash point apparatus we need to use. So that values, maximum values 93, 99. Then beyond that is no problem. If it's higher flash point means again it's trouble in our combustion. So alcohol and also methanol content mass percentage is maximum. Then flash point. Then water and sediment. So yes, I will show a very good diagram about this microbial growth inside the biodiesel. So the water and sediment, the percentage volume. So this should be 0.050. Then viscosity. Yes, the viscosity is a resistance of flow of fluid The kinematic score determine the fuel injection characteristics. So this should be within the range of 1.9 millimeter square per second or centistokes to 6 this range. Then sulfated ash. The sulfated ash means the presence of catalyst in the biodiesel. That may represent the sulfated ash, alcoholic catalyst. Then copper strip corrosion. After maintaining 3 hours at 50 degrees centigrade, what is the color of copper strip inserted in the biodiesel? That should be value is 3. Then CTA number. A CTA number is very difficult to find, but for approximate CTA number, we can calculate in terms of CTA index that I will show that diagram. Okay, the value should not less than 47. If it less than 47, we cannot consider this a biodiesel fuel. Even if they are not having the proper ignition quality, we can neglect it. Then cloud point, yes, the cloud point may be varied with the different feedstocks. We cannot have the proper control over on cloud point, but everything is based on the fatty acids. Fatty acids present in the cloud points. Fatty acids present in the vegetable. Sorry. Then carbon residue. So after combustion, whether any carbonaceous materials present in the combustion chamber that we can find, but that value should be 0.050. Then acid number, the amount of free acids, free fatty acids are present in the biodiesel, that can be calculated by amount of potassium hydroxide is equal to neutralize the free fatty acid per 1 gram of oil. This is mgh 0.5. Free glycerin and total glycerin. So the glycerin is available. The glycerin available in the biodiesel can be determined with the help of gas chromatography and mass spectrometry. Then pass plus contrast, again the trace material. Then distillate temperature. So initial boiling point, what is the initial boiling point? What is the middle boiling point? What is end boiling point? These are things that we can find. Using this value, we can approximate the cetane number. We cannot have the proper control on the cetane number because the cetane number, we need to do some experiment on pre-combustion chamber diesel engine. Then we have to compare it with the fuels. The cetane number we are having only diesel standards. We are not having biodiesel standard methods, but we can approximate it with the help of distillation temperature. Then sodium, potassium. Yes, again the traceable amount. Then oxidation stability. Yes, this is oxidation stability should be 3 hours. Minimum 3 hours. Oxidation stability. Okay, these are the requirements for 100% biodiesel. I forgot to tell that this is a requirement for 100% biodiesel as listed ASTM D6751. These are fuel characteristics. So on the next slide, which does the biodiesel blends. What are standard procedure in the biodiesel blends? What are the maximum limiting range or allowable range? Yes, yes. RC numbers. Continue, sir. Yes, there is a biodiesel blends B6 to B20. These are the factors: the CTA number, CTA index, the ash content, something. We will discuss one by one. Yes, the first one is this slide shows a method to find free and total glycerin or glycerol present in the biodiesel. Yes, the test method is ASTM D6584. The maximum allowable limit is 0.020% for free glycerin or 0.240% of mass for total glycerin. This can be easily obtained by gas chromatography with the FID detection. So the gas chromatography and FID detection, this type of apparatus is available in throughout India. Or if you go and refer some SICRI or even there is a Sigma laboratories, even this some private laboratories, we can do it. Okay, the gas chromatography, the FID detection, even the SIFE and IIT. So the quantity is glycerol, and it will give us how much amount of glycerol, mono, di, and triglycerides are available. This is a gas chromatography FID detection measured with the ASTM standard D6584. So the saturated monoglyceride is very low solubility in the biodiesel. If too high, it will affect the fuel filter plugging and fuel stability. Very much interesting. Once you produce a biodiesel, we need to store it. Once you store it, definitely the fuel properties keep on detracting due to some oxidation stability problems. Okay. Yes. So in my research work, I determined the fuel properties of waste cooking oil, particularly it's palm oil, and its methyl ester. Means waste cooking oil, waste cooking palm oil based biodiesel, and different brands of diesel and methyl esters. That is I determined all the parameters at IOCL Trichy. So the calorific value, CTA number, specific gravity, and viscosity, and the cloud and pour point, flash and fire point, and the corrosivity, copper strip corrosions, and the sulfur content estimations. Okay, these are all things that I determined at Indian Oil Corporation, Trichy, and some property I have collected from CPCL, Chennai. So we need to go for this all the points. This means, so for I keep on telling, no, there is a, we need to find the acid values before going for transcription. We need to go for find the acid values or acid number of the particular vegetable oil. From that we can control the transesterification process. If the free fatty acid content of the particular vegetable oil is higher, means we can go for two-step transesterification process. Okay, so this slide, yes. Then next we are going to discuss about how to determine the density, kinematic viscosity, and the sulfur content. I am going to suitable video clipping and a pour point and a cloud point and flash point, and a CTA number and a calorific and the carbon residue. These are things we are going to cover. If time permit, I will show the video clipping. Otherwise, we will discuss some data related to density and discuss some different important properties. Yes. This slide explains the method to determine the density of biodiesel and biodiesel blends as per ASTM D1298. We go to in which the hydrometer is this is not the hydrometer. Hydrometer of the suitable scale, and maybe nowadays in types of density scales are available. And some hydrometer we are having some specific gravity values from 0.82 and 0.8 to 1 or 0.6 to 1. Likewise, we are having some specific gravity values. So the hydrometer with suitable scale will be placed in a 100 ml, 1000 ml measuring flask along with a thermometer. The whole setup will be maintained at a temperature 15 degree. There is as per ASTM 1298. Once steady state will reach us, that means we got to wait and we will observe the density of the sample. So then the meniscus value we can find. However, there is the one more interesting point. We got to wait for some time. Otherwise, it will not give the proper values. We need to wait. The temperature available in the thermometer should be 15 degree, not room temperatures. Okay, so interesting point. We have to wait some time. Otherwise, we will get some wrong answer. But we have to take 3 to 4 readings and we have to consolidate it. We have to sum up the values. We can find as the density of particular fuel or fuel blends. Yes. So from this, I have from this hydrometer, I have collected different type of different fuels density. Yes. First one is Indian Oil Corporation diesel. Yes, it is 826 kg per meter cube. Then market diesel is here during the transit the density may be vary, or maybe some different water sediment present in the tankers. The density will be decreases. Market diesel is 823.5. Then raw palm oil. Yes, the raw palm oil. Normally available cooking palm oil is raw palm oil. The density is 920.5 kg per meter cube. Then esterified or transesterified, the biodiesel, pure biodiesel is 886.7. Then if you add the 5% of diesel, the density get reduces. Yes. You see the density value 840, 846, 848. So when you keep on adding the when you keep on adding the that means the 5% of biodiesel is added with the diesel B5. Then 10% of biodiesel is added with the 90% of diesel. 15 means 15% of biodiesel added with the diesel. So here the density of the market diesel is IUCL is 826 or 823. Just keep on increasing because of adding biodiesel. But keep on increases. Yes, the next slide, which gives details about determination of kinematic viscosity as per the standard ASTM D445. So the kinematic viscosity is a measure of resistance of fuel to flow. Yes, you know that. It is the most important parameters which determine the fuel spray pattern inside the combustion chamber of an engine. Or the fuel blend or the fuel or test fuel or fuel blend will be taken in inverted U-tube manometer. So inverted U-tube manometer. Inverted U-tube manometer. This setup is placed in a hot oil bath at a temperature of say it's 40 degree. This is as per standard 40 degree. Once it reaches the steady state condition, we need to note the time taken for fuel to travel between two markings present in the bulb, U-tube manometer bulbs. Two markings there. So how much time it will take from travel from one point to another point? We need to note. Using the time taken and the constant for this kinematic viscosity setup, we can easily calculate dynamic viscosity of biodiesel and its blends. You can see this step-by-step procedure by those video clipping, but I think I will check it. I check this. Yes. Please click. Is it audible, sir? Is it audible, sir? Is it audible, sir?
Audible, sir.
Yes, sir.
Audible.
Audible.
Yes.
Sir, Kannan, sir, audible.
Okay, sir. Okay, sir.
Engines are designed from certain viscosity and fumes. For butterflies to be considered drop and fuel, they must perform similar to petroleum-based fuels. Viscosity is a degree of a material's resistance to flow. Low viscous materials flow quickly with water, and high viscous materials flow slowly. Kinetic viscosity is the ratio of the absolute viscosity divided by the flow density, which is measured in centisteps per millimeter squared per second. Kinetic viscosity is more relevant than flow rate. Biodiesel typically has a slightly higher kinetic viscosity compared with petroleum diesel, around 4.5 centisteps per biodiesel, 3 centisteps per diesel. The acceptable viscosity of biodiesel according to AICTE is 6750 is between 1.9 and 6.1 millimeters squared per second. The kinetic viscosity of volume for biodiesel is higher than the volume for normal diesel, which is 4.1 millimeters squared per second. Since as high viscosity is difficult to control, we can have issues with mineralization, which can lead to broken material and increased emissions. Temperature and heat sources for biodiesel affect the kinetic viscosity. The kinetic viscosity for biodiesel and diesel decreases with an increase in temperature. Petroleum diesel and biodiesel have similar rates of kinetic viscosity to temperature, even though the rates are similar. There is a greater difference in lower temperatures between biodiesel and petroleum diesel. By blending biodiesel and petroleum diesel, a blended fuel has reduced viscosity compared to the biodiesel. Blended biodiesel is recommended in temperatures. In the discovery using suitable solids by passing clean dry filter air through the instrument to remove the fine traces of solid. Charge the sample into the dissolver and convert the instrument by suction to the large tube, immersing the small tube in the liquid sample. Control the liquid to the second line, rising and turning the instrument to a solid fermentation. Place the dissolver into the filter and insert it into the 12-cent temperature barrel and shine it over the liquid.
Okay, so I hope that you may have some idea on how to calculate this kinematic viscosity using this viscometer. Okay, so using that method, I found that different type of kinematic viscosity of my test blends. So the diesel.
Sir, you are in mute, sir.
Kannan sir, you have muted.
Okay, sir. I'm audible, sir, now?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Yes, sir. So, using that kind of viscometer concept, I prepared some, I found some kind of viscosity of my test blends. So, the diesel, the kind of viscosity is 2.6 centistokes, and the raw palm oil, it's a 31.44 centistokes. Likewise, the B100 is 4.86 centistokes. Likewise, they keep on this, when we add the biodiesel into the diesel, automatically the viscosities keep on increasing. But you can see this from this, you can see this, the raw palm oil. This we can use raw palm oil as a feedstock or a fuel for engine, but it has a higher kind of viscosity, so that way it will affect the fuel characteristics and fuel spray patterns. But when we go for transesterification, it's almost reduced to 4.86. It's then nearly it's 27. And so may lost the help of our transesterification process. Yes, this is one more explanation about this different general aspects of biodiesel with number one diesel and number two diesel for all the category. When the temperature increases, the viscosity decreases. So you know that. Okay. So this the canola methyl ester and the soya methyl ester and the fish oil methyl ethyl esters, they have the same blends, but we have to take care of the regression equations constants. So that's all about this kinematic viscosity of how to determine the kinematic viscosity of biodiesel and biodiesel blends. The next slide will give some information related to sulfur content of the biodiesel. Yes, we know that sulfur, there is no sulfur content, sulfur present in the biodiesel. But when you go for the blends, so the 10-20% of biodiesel mixes with the diesel, we need to find the sulfur content. So using even 1% of biodiesel, one interesting point, 1% of biodiesel will give some lubricity for diesel fuel. Almost 65%. It will give lubricity. You think about it, we can consider this biodiesel as a lubricant in the diesel. So then, yes, here how to find the sulfur content. The sulfur content can be calculated with the help of the AICTE D5453 procedures. So in which we are going to use some ultraviolet fluorescent concept, UVF concept we are going to use. So the test sample or hydrocarbon liquid sample or biofuel sample is directly injected into the completely automated liquid sampler into a high temperature, dual temperature, or the composition tube is there. They are going to heat it. Then once you heat it, then that means the ultraviolet rays may be passed into the test sample. Due to the heat, automatically the hydrocarbon liquid or biofuel may be vaporized. So if there is sulfur present, there is a biodiesel, no problem. But if it's a biodiesel blend, definitely some quantity of sulfur is present. The sulfur is oxidized into sulfur dioxide. So the sulfur dioxide is observed. Yes. Next I show this. This sulfur content. How to do this test equipment using ultraviolet fluorescent techniques. UVF. Okay. So the sulfur dioxide mixes with the ultraviolet. Sulfur. There is some unstable sulfur dioxide. Then the unstable sulfur dioxide will be in an excited condition. It releases some light or emits some light energy. The light energy may be observed with the photo observer tube. Then that may be suitably correlated. We can get the sulfur content. Okay, this is a constant of sulfur content. But the sulfur content, yes, we know that this is yes, the IOCL diesel. The sulfur content value means 496 milligrams per kg. Market diesel 459. Into the milligrams. Don't get me wrong, milligrams. This is an allowable limit. So in the raw oil, that means the palm oil, there's no change. But again, this is a big hunter, and maybe error or some percentage of this. So we need to properly clean the crucible. Here the crucible is there, no? We need to properly clean the crucible. If we are not properly cleaning this crucible with solvents, it will give some error. 51 or 50. But anyway, that is in allowable limits. Allowable limits. Maybe it's a 0.005 something. Okay. So here when you add the biodiesel, you see this the B5 491. When you add the biodiesel, the sulfur content of the biodiesel blend keep on decreasing. Then the quantity of biodiesel increases. This is B10, B15, B20, B40, B60, B80. That means the sulfur, the biodiesel not having any kind of sulfur content. But you may think that here is the 51 is percent, 51 may be some error. Okay. So the next topic, yes, the next topic we are going to cover, that is a copper strip corrosion test for ASTM D130. The copper strip corrosion test. There is a standard procedure is a D130. Its main purpose to measure the degree of corrosivity of test materials or test fuels. Corrosive nature of the fuels. So most of the engine parts are made up of copper or bronze or copper-based alloys. So we need to take care of corrosivity of or corrosive nature of the particular test fuel. Test method covers the determination of corrosiveness to the copper of any kind of fuels: aviation gasoline, aviation turbine fuel, automotive gasoline, cleaners, solvent, kerosene, diesel fuel, distilled fuel oil, and lubrication oil, and natural gas. Everything coming under this ASTM T130. Even it's a biodiesel also. But interestingly, that particular fuel or particular hydrocarbon having vapor pressure not more than 124 kilopascal. That is standard pressure. So here, this is a copper strip corrosion, ASTM D130. Here, very interestingly, so the copper strips will be cleaned. So the copper strips first. The copper strips will be cleaned with some cleaning agent. Then it will be immersed in the standard tubes, the standard metal canisters, standard metal cylinders, which will be inserted. It's already filled with our fuel samples. The whole canister is like a whole canister is placed in a setup, or maybe placed in a setup, or maybe immersed in a hot water bath, which is maintained at a temperature of 50 degrees for 3 hours, minimum 3 hours. Then the color of each copper system will be compared with the ASTM templates. This is the thing. So here the ASTM template, there is ASTM standard template. We are having straight tarnish, maybe represented as a graded as a 1A, 1B. Moderate tarnish is graded as a 2A, 2B, 2C, 2D, 2E. Then dark tarnish is marked as a 3A, 3B, and a corrosive nature. If it's a fuel is corrosive nature, means after 3 hours, the copper maybe looks like this color. That's like black box. Then 4A, 4B, 4G. But as per the ASTM D6751, the 3A is up to 3A suitable for, that may be considered as a good fuel characterization. Here you can see this. So see this. The slate tarnish light are almost same as the freshly polished strip. And slate tarnish 1B category may be considered dark orange, a claret red, and a lavender. Some concepts there. So the results may be reported as a comparison with the standard chart. This is standard chart, ASTM standard chart. Here, yes, after the copper strip corrosion, for my test fuel, diesel is there is no change, raw palm oil there is no change, estified B100 is a biodiesel, there is no change. That means almost maybe 3A category, and BET also 3A category, the dark tarnish type. Then B10, B50, B20, B40, B60, B80, there is no change. B80 and B100 may do slight blackish. That may be within 3A. Yes, that may be tabulated. So here the fuel, the diesel 1A, raw palm oil, and B5, and B10, B15, B20, B40, but here 3A and 2. So if you use a biodiesel, the prolonged usage of biodiesel will affect the copper. There's some different engine copper based materials in the engine. So we need to take care of this. Or corrosive inhibitors we have to use. So one more point, the corrosive inhibitors. Some chemicals we need to add to control this corrosion. So next we come to this one more interesting point, that is low temperature operability parameters. Yes, it's a pour point, float point, then cold filter plugging point. Okay, so the pour point is very simple one. The ASTM standard for pour point is D97. It's the lowest temperature. It's the lowest temperature at which the fuel can pumpable. Lowest temperature at which fuel can pumpable without any stirring, or at which the product continues to flow when it's cooling. Yes, anyway, we are going to maintain some minus values. Lowest temperature at which the fuel can pumpable without stirring. That is a pour point. The float point distance, it's measured with the help of the ASTM standard D2500. It's the lower temperature at which the first wax formation is observed, or within a fluid under test precipitation, or at what point the precipitation forms during the cooling. That the corresponding temperature is known as the float point temperature. Then the cold filter plugging point is a method to use to determine the low temperature operability of diesel fuel, biodiesel, fuels, and gas oils. It's a critical property to find the fuel will freely flow through the filters in diesel engine or not. This here you can see that the cloud point maybe says cloud point may be 5 degree, pour point may be minus 5 degree. The CFPP should be in minus 2 degree or minus 20 degree. So the CFPP will be always between this pour point and cloud point. Okay, so I'm going to show the diagram first. This is a low temperature operability parameters. That is very much essential fuel characteristics for biofuels. Yes, the pour point. Yeah, so the cloud point and pour point of test fuel or biodiesel will be determined using deep freezers. But in the case of at the time we were used the deep freezer to find this cloud and pour point. So in the deep freezer temperature capability up to minus 30 degree. The test sample will be yes. As usual, the test sample will be taken in the test tube. And the thermometer placed in such a way that the bulb of thermometer just cover the test samples. Then it will be placed in a deep freezer. Every 1 degree drop of deep freezer, the visibility of test sample will be investigated. Visibility will check. The temperature at which wax or precipitation forms will be considered as a cloud point. The cloud point. One wax formation or maybe some precipitation formation inside the test sample means that corresponding temperature is called as a cloud point. The pour point, yes, the temperature, yes. After determining the cloud point, the pour point will be found by considering the temperature at which the test sample can be pumpable. But almost here is a solid state, but it's even some liquids are present. That time is known as a pour point. Then CFPP will be determined by considering the temperature at which, yes, you know that fuel will freely flow through the filters in a diesel engine system, which is in separate ways. The detailed video clipping will do some elaborate procedures. Please wait. So is it audible, sir? Is it audible? Visible? Yes, sir?
Sir, yes, you can proceed, sir.
Yes, okay. Yes, sir.
ஜாலியா இருக்கீங்க.
Okay, sir. So this idea to find is a cloud point. The 4-point test and the CFPP test in time limit will discuss. I will show this show the video clips. Okay. So the next important, yes, the 4-point. I'm audible, sir. I'm audible.
Sir, yes, sir, yes, sir.
Pour and cloud point. Oh, yes, sir, please. The pour and cloud point temperature. So based on the deep freezer test, we found that there is a pour point of diesel is -6 degree and the cloud point is 4 degrees. So once the diesel reaches 4 degrees centigrade, we can get some precipitation in the diesel. Similarly, for raw oil, that is a palm oil, 0 degree we can get a precipitation. Up to -5 degrees centigrade, the raw palm oil can easily pumpable. Then the esterification, yes, say the pour point is 0, the glow point is 4 degrees. Like this, the thing is the blend maybe they are having some different values. So the next one is flash point. As we all of you know that the flash point, the main purpose of the flash point is to determine the storability and the fuel handling facility. So the flash point can be determined with the help of automated Penske marking closed cup apparatus. So the estified, so based on the thing, yes, actually this one is a closed cup Penske Martin flash point apparatus. We can find there is a estified fuel, estified or transistor biodiesel stored 140 degrees centigrade compared to diesel. So 142 degrees centigrade is okay, well and good for safely transfer the fuel, storage and transfer the fuel. But I think when you go for the combustion, it may affect some percentage. Okay. And then raw oil, the flash point is 220, and diesel is only 42 or 45 based on the batches. Okay. So the next one is the CTA number. Yes, the CTA number. This slide shows a method to adopt, method adapted to calculate the CTA number as a CTA index. Okay. So, however, we are not having the proper standard procedure for calculating the CTA number. The CTA number calculation also or determination also very expensive process. We need to approximate the CTA number with the help of CTA index. Some equations we are going to use. In order to obtain the CTA index of test fuel, we need some initial boiling point, middle boiling point, and end boiling point. For that purpose, we are having some different type of distillation apparatus. So before that, what is CTA difference between CTA number and CTA index? CTA number is yes, CTA number value. This CTA rating present in the diesel. Okay. So the CTA number is determined at a constant speed in a pre-combustion chamber type combustion engine. In India, we are having only one apparatus to find the CTA number. In the CTA number, scales cover from 0 to 100, but the range is from 30 to 65. This is CTA number. But the CTA index, there is some approximation of CTA number of the particular fuel blend we can find. It's a measure of ignition quality of diesel fuel based on the ignition delay in an engine. If it's a higher CTA number, short ignition delay and better ignition quality. So an approximation that correlates with the diesel fuel aromatic contents based on the empirical relationship with density and volatile parameters such as middle boiling point. So in order to calculate the initial boiling point IBP and MBP and EBP, that is middle and end boiling point, we are having distillation apparatus. This actually is a double distillation apparatus. Simultaneously, we can get two distillation. We can go for double distillations. So here we can use the test fuel will be taken in cross-leg open type round bottom flask. I will show the diagram next. The cross-leg open type round bottom flask. The top of the flask is covered with suitable range of thermometers. Top of this suitable thermometer and the condensation of test sample. Here, the back side of this frame, we are having some condenser. The condenser, we are converting all the vapor into liquid. Then here, the condensation or condensate of this sample will be collected in 1000 ml measuring jar. Okay. So for each cases, what is the temperature? We need to know. So you see this. This slide shows the position of thermometer to measure the vaporized test fuels. Yes. We go to place the thermometer like that. So once the vapor comes out, vaporized test sample comes out, then it hits the bulb, the temperature we can find. Then the vapor may be passed through the passage where it condenses. Then the content will be collected in the 1000 ml measuring jar. 1000 ml measuring jar, we can collect it. So the temperature will be noted for every 10% volume of condensate collection in the measuring jar. Using the density of fuel and volatile temperature values, we can calculate the CTA index. This value may be approximation of CTA number only. We cannot say CTA index of biodiesel. We cannot say this is only approximation. We are not having the proper ASTM standard for finding as Ctn index. Ctn index is approximation of Ctn number. So here you see this. This is my test fuel. So raw oil, the initial boiling point is 225. The esterified oil I didn't mark. There is a B5. So B100 we cannot run it because for B100 biodiesel in the vapor pressure is so much high. So that's why the biodiesel will not vaporize. That's why we didn't go for the B80 or B60 something. B100. So B5, 5% of diesel is 5% of biodiesel added under the diesel, initial boiling point, 10% volume correction at 190 degree, at 305, at 370, and the temperature will be 350 or 370. The maximum temperature, 90% volume correction. The temperature of the particular fuel is 370. Like this. So in the C10 number, so based on the equations, we can collect and we can put the value of 57, 57, 53, 53, 58, but we cannot call, we should not call this a C10 number, this is C10 index, but this approximation. Okay. The series, one more failure here, this slide shows the atoms made to find the initial boiling point and end boiling point of raw cotton seed oil, but it was failed due to high vapor pressure. Just like our best cooking oil. You see this. Okay, this the oil will not come out. But for that we need to go for we need to change the pressure, different pressures. We need to go for vacuum pump to modify the pressures. So this slide is gives a photograph view of the property determinations. Yes, for core and cloud point, then Kannan viscosity, then CT number, CT index, then sulfur content, then flash point and copper strip correction. So these are things are I determined in IUCL Trichy. The next, this next interesting is one more thing is called that is determination of carbon residues. Particularly is a contraction carbon residue CCR, con carbon, or it may be indication of coke formation tendency of particular biofuel. The test measures the amount of carbonaceous residues present in the oil, evaporation, and the pyrolysis, even it's a combustion. Okay. Here interestingly, we are having some carbon residue apparatus that is called the Skidmore. In the crucible is there. I think you can see the crucible in which we have to place 2 to 3 grams of oil. Then we have not on its weight along with the crucible. Then we have to place the crucible inside the Skidmore crucible, iron crucible. Then our whole things are placed in the hood and chimney arrangement that keep on heating it. We keep on heating it. Automatically after combustion, the flame smoke maybe comes out. Again, we have to burn the smoke with the help of flame. Smoke we have to bring after 10 to 15 minutes. We need to take the crucible and again we have to measure the weight. And the difference in the mass of this or the difference in the weight of the particular crucible will indicate the carbonaceous residues present in the particular fuel. Okay, I'll show the video clipping related to carbon residue ASTM D189. So the glass beads to added to avoid the agitation of this material, agitation of this oil. So we need to weight it. We need to measure the weight. So I think they are going to check the carbonation material present in the crude oil. So with the crucible is placed in the Skidmore crucible, iron crucible. This is Skidmore iron crucible. The whole thing is placed on the container arrangements. Yes, we need to burn the smoke. Some oil vapors are there. Again, we need to measure the weight of the crucible. This is called a Skidmore iron crucible. So this is a method to find the carbonization material present in the biofuel or even oil, lubricant oil. Same procedure we have to follow. Shall you next sir? So the next is one interesting fact about this biodiesel agitation stability. Yes, this that is agitation stability. The agitation stability can be determined with the Ransomware test. That's again it's an expensive test. So the ASTM D93 we need to follow, that standard procedure we need to follow. But we are having two more ways to find the agitation stability with the help of some fatty acid presence in the biodiesel. So the agitation stability. So here is this. And the main drawbacks of biodiesel is its degradability, which occurs when at what condition degradability occurs. So when the biodiesel is exposed to the air or sunlight, the degradations keep on keep on creating some unwanted material inside the biodiesel. It may create some peroxide and some other things. So what is happened inside the biodiesel during the agitation? Okay. So the presence of the agitation susceptibility is linked to presence of unsaturated fatty acid in the esters. So once we remove the unsaturated fatty acid, then we can have very good control over the agitation stability of the biodiesel. So the biodegradability is inevitable from the environmental point of view. But anyway, once the biodegradability of the biodiesel takes place, automatically it will affect the fuel characteristics. Okay. So we can, once the fuel characteristics is low at the standard level, we cannot consider the biodiesel as a fuel for CNGs. So oxidation is very well known to alter the physiochemical properties as well as tribological properties. Yes, wear and lubricity during the storage. So the main problem is the phenomena is resultant in insoluble deposit. So when it's exposed to the oxygen, what will happen when it's exposed to the biodiesel exposed to the air? Automatically it creates the insoluble deposits, which increases the different properties such as numbers, peroxide values, kinematic viscosity, density, and iodine value, and the polymer content. These all things are keep on varying. So the oxidation stability, yes, again the same points repeating. So the oxidation stability affect the fuel properties. It may impair the fuel quality and engine performance. So whatever may be, but anything, but the most of the cases, we need to know the fatty acid composition present in the biodiesel. So the fatty acid composition may be determined with the help of yes, in the gas chromatography and mass spectrometry. Then here this slide which gives some clear picture about the fatty acid composition. PUFA, that is polyunsaturated fatty acids. It consists of more than one double bond in their backbone. It's oil molecules. Oil molecules we are having. So linoleic acids, this is polyunsaturated fatty acids. Then monounsaturated fatty acids, MUFA. Then saturated fatty acids, SFA. There is no double bonds. I will show one more slide for easy understanding. So the saturated fatty acid, no double bonds are present. If it's unsaturated, it may be double bonds. Then here, unsaturated, two unsaturated. So here the double bonds, the mono unsaturated and poly unsaturated. Here, yes, the fatty acid may be classified as saturated fatty acid, mono unsaturated fatty acid, and poly unsaturated fatty acids. So the oxidation stability can be calculated with the help of one formula, that is one empirical equations. Y equal to 111, 107, 7 points. The point is a mistake. Is a point 9295 divided by x plus 2.5905. X value is start from 0 to 100. X is the content of linoleic and linolenic acids. The linoleic and linolenic acid can be calculated with the help of nuclear magnetic resonance NMR test. NMR test, we can find the acid content, percentage of acid present in the, or weight percentage of acid present in the biodiesel. We can find. From that, we can calculate oxidation stability in terms of hours. We can find. So one more formula for calculating oxidation stability is OS equal to minus 0.234 into x plus 22.318. Here x may be ranges from 0 to 84. X is nothing but unsaturated fatty acid methyl esters. So here methyl ester unsaturated and polyunsaturated monosaturated can be determined with GSMS, gas chromatography. We can find. Yes, this graph gives fatty acid composition and oxidation stability of various biodiesel. I have taken this from one very good paper, that is oxidation stability by one Indian author. So the fatty acid composition and oxidation stability of different biodiesel is represented in this diagram. Here, the fatty acid composition in this axis. Here, the bottom we are having various biodiesels. Here, PUFA is nothing but polyunsaturated fatty acid. MEF is nothing but monounsaturated fatty acid, and green SUF is nothing but saturated fatty acid. Saturated fatty acid. O is nothing but oxidation stability. Here in this graph, we can easily find that the maximum oxidation stability of 18 hours, say 18 hours, and 16 hours, and almost 13 hours for acai and palm oil and passion fruit oil respectively. From these curves, we can observe that more weight percentage of MUF. In this case here, more weight percentage of MUF and SUF will provide maximum oxidation stability. But when we remove this polyunsaturated fatty acid, we can have a great control over the oxidation stability. So the limit of biodiesel, but however, here for all the oxidation stabilities, almost all the biodiesel is oxidation stability for 3 hours. The biodiesel blend for 6 hours, but here is oxidation stability in terms of hours. The maximum oxidation stability is for this acai oil, then you see this passion fruit oil, then palm oil, almost 16 to 17 hours. Okay. So the biodiesel characterization here interestingly. Yes, sir. Sir, can I proceed? So here the biodiesel degraded due to one or combination of the following reasons. Yeah, maybe oxidation in the presence of oxygen, thermo-oxidation at elevated temperature when the heat is keep on heating is harder. So I am placing the biodiesel storage can in front of sunlight or in the nearer to some hot room. Then thermal oxidation takes place. Then hydrolysis in presence of moisture. So some quantity of water are present in the biodiesel automatically creates hydrolysis. Then microbial degradation due to presence of bacteria and fungi. Then various factors which influence the oxidation process of fatty acid. Yes, discussed presence of certain they have discussed in elevated temperature and some materials package like and expose the but these factors might be as a catalyst to change the taker of oxidation stability. The oxidation stability can be experimentally calculated with the help of Ransom test, but with the help of fatty acid composition and with the help of some of the acid compositions, we can approximate the oxidation stability. Yes, during the storage, changes occur in composition, particularly acid value affects the oxidation stability, density and viscosity, peroxide values, induction period, and flash point. All those things are varying. That is variation of properties mainly due to formation of hydroperoxide, aldehydes, ketones, and acetones in the biodiesel due to oxidation. Here, one interesting point: the acid number of biodiesels keep on increasing. So I think very beginning of this session I told that the acid value is a very good very first parameter we need to calculate. So once the acid values keep on increases, we need to go for different type of transcription methods. So the acid value of biodiesel increases sharply upon oxidation. Further increase in oxidation values due to storage time and storage temperature. But thing is, the primary oxidation means hydroperoxide is formed inside the biodiesel. Once it exposed to the atmosphere, once water present in it, or maybe the thermal heating, so or the thermal treatment. Because of that, the hydroperoxide is formed inside the biodiesel blend. But in the case of increasing AV is mainly due to secondary oxidation. So after hydroperoxide formation, aldehyde and acid formation takes place inside the biodiesel. That leads to increase in the acid value. Once acid value increases, what will happen? It will affect all the fuel supplying system. Yes, one more interesting point: the biodiesel absorbs the water, causes hydrolysis of esters. Again, it increases the acidity increment. Okay, this acid value behaviors. Yes, the acid value may be determined with the help of ASTM D664. Particularly, it may be used with some simple titration procedures, or maybe some indicators are also available. Yes, here the acid value. From this tabulation, you can find the acid values of the first column represent different biodiesel, and the second column represents the storage temperature. Different storage temperatures are minus 15 degree, room temperature 40, minus 50 likewise, and then some different temperature 4 degree up to 4 degree. The storage duration 4 months, 12 month period, and 6 month period with the different storage conditions. Yes, the A represent not exposed to the air, B represent exposed to the air, and 5% water and not exposed to the air may be represented as C, and 5% water and exposed to the air D is expressed as a D. Then the closed container and artificial light may be the one more condition, and open in air and direct sunlight. Is here you can note it. The initial acid value is 0.01 milligrams of kWh per gram, maybe increases 0.07, 0.1, 0.34. Say up to this here, you see this. For rapeseed oil, when maintains a solar temperature of 40 degree for the period of 12 months means initial acid value of 0.15 will increase up to 19.3. But the condition is D, 5% of water and exposed to air. Even this is Jetroba. Here in India, we are trying to mix Jetroba biodiesel with the diesel fuel. So here for 6 months storage, 6 months storage duration, 0.14 acid value may be increased to 0.44. But when it's open air and air sunlight, this is an impact. This is the impact of oxidation acetic value due to oxidation stability. Then yes, the peroxide values. One more factor. The peroxide values represent the degree of oxidation, not stability. Degree, it will indicate the degree of oxidation of the fat or oil. It's not means with the oxidation stability. How much degree of oxidation happen inside the biodiesel, that may be represent the peroxide value. It is directly affect the ignition quality, that means CTI number. Increase in peroxide value is a function of storage time. It's mainly due to free radial axis. The temperature, light, moisture, metal, and oxygen affect the rate of oxidations. Then the kinematic viscosity we discussed. So because of the oxidation, the kinematic viscosity keep on increases. That is mainly due to the insoluble long chain formation, long chain saturated component formation, sediment, gum, and polymers, which can be potentially plug the fuel filter and injection systems. So here the peroxide formation formed during the oxidation also creates some formation of gums and sediments. So this is a phenomena to increase the kinematic viscosity. Here, yes, the one more tabulation which represents changes in kinetic viscosity of different biodiesel upon storage at different temperature and conditions. Here you can see this first as usual biodiesel, the second column storage temperature, the storage duration for in terms of months. The viscosity maybe increases for a period of 6 to 12. We see this in the Jetroba for the storage during 6 months. The 4.38 initial kinematic viscosity is increased to 5.63 because of these parameters. Some gum formation and the gum and polymer, which can potentially affect the filters and injection systems. Then the density, yes. This slide shows some ideas about different fuel properties. Say it's the oxidation effect on basic fuel properties, namely density, yes, heating value, and iodine value. So here the shorter chain hydrocarbon and more saturated fatty acids is more prone to be crystallized. So oxidation density also increases. Then heating value, steady decrease in heating value of biodiesel because of oxidation. formation of shorter peroxide component. The short peroxide component forms means its the degree of oxidation is higher. So the oxidation fuel cards iodine value, degree of unsaturation. Iodine is the lesser of degree of unsaturation. This also decreases. It decreases upon storage. Degree of unsaturation, because if it's a saturated biodiesel, we can get poor oxygen stability. Then the effect of different metals on oxygen stabilities. Yes, different metals, the trace metals present during the chemical reaction, biodiesel chemical reaction, that may act as a catalyst and accelerate the peroxide formation. Then these are some metals, the strongest: copper to copper, cobalt, manganese, nickel, and Fe. Apart from that, aluminum, zinc, brass, and bronze are also not compatible with the biodiesel. Yes, here this graph represents the effect of different metals on oxidation stability of different biodiesel. There is cotton oil methyl esters, COME, and the combinations. There is, if it's a C, there is a C plus Fe. There is cotton oil plus iron, cotton oil plus nickel, and manganese, and the cobalt, and Cu. This is represented in the bar charts, and the graph curve represented in terms of moringa oil methyl ester, MOE, MOME, M plus Fe, M plus Na, M plus manganese, like this. So here you can see this, the values keep on, the trace materials keep on decreasing the oxidation. There is an induction period. Induction period is a period of time before oxidation products from forms a biodiesel. Forms as biodiesel begins to age and degrade. What is the induction period? Before the oxidation takes place. What is the induction period? The induction period keep on decreasing. The quantity increases. Then yes, then we are going for some antioxidants. The antioxidants and oxidation stability of different biodiesel. So the dissimilar molecular structure, the existence of different temperature, and amount of blending with biodiesel and amount of doping. This will be affects. Here we are having some PG, PY, DBHQ, BHA, some different antioxidants placed in the available means it will affect the oxidation stability. Then in order to maintain the oxidation stability, we can go for blending of two biodiesel. Yes, palm oil and jojoba oil and sunflower oil, like this. So here see this lower oxidation stability is combination of this jojoba oil and sunflower oil with a different percentage. Likewise, the tertiary oil also we can go for oxidation stability, different percentage. We can control the oxidation stability. But the other properties, yes, the wear and tear also, the short duration of oxidation, weaker the wear and lubrication characteristics, longer duration of the improve characteristics, and the degradation of properties such as total acid number, peroxide value, viscosity, and this is a function of time, temperature, and exposure. One more interesting point. So due to the oxidation problem, the BSFC value increases because the oxidation stability will decrease the heating value. So at the same time, the oxidation stability decreases all the tailpipe emission except in NOx. Then one more thing is the sulfated ash. Yeah, this is one more thing. There is ASTM D874, which represent whether it's alkali catalyst present in the biodiesel or not. This method is ASTM D874. So it's water and sediment we can find. So if the water and sediment can be found out with the help of ASTM D2709, maximum allowable is 0.05. But if the water and sediment present to affect the corrosion, it will create some corrosion problems. Then the water and sediment is the high level traces, high level groups of 1 and 2 metals, sodium, potassium, calcium, and a magnesium can deposit and form create some undesired side reaction. Okay, but the value is limited to 5 ppm. So next we move towards the biodiesel material compatibility. The biodiesel is very much prone to some different materials like brass, bone, and lead, tin, and zinc, and even some plastics. But the biodiesel blend 20% will not have that much effect on it. But B5, B2, there's have no noticeable effect on material compatibility. So biodiesel material compatibility, we have to go for some elastomers and different type of written materials. We can go for biodiesel material compatibility. Then the last point is the biodiesel microbial growth. Here, yes, the bacteria, fungi can grow in the diesel tank. So the bones, the bacteria and fungi are present in the diesel fuel tank means it will create some water molecules. It may create some water molecule. So water is to periodically remove. So sometimes the biocides can be available to control the microbial growth in the biodiesel. So otherwise the dead microbes can still like the filters. Okay. So the bacterial growth and the fungal growth for the photographs. So before implementing anything, so the biodiesel certificate of analysis must be done without any negligence as per format before. So far, we have discussed the few important fuel characteristics like density, kinematic viscosity, CT number, sulfated mass, and the trace of metals, and the glycerin, acid values, and oxygen stability, part of oxygen stability. We can use any kind of feedstock to produce a biodiesel. However, the biodiesel or biodiesel blend must meet ASTM D6751 in order to satisfy the fuel characteristics, meet engine combustion requirements, provide lower emission profile, and also maintain the long-term storage to sustain the green energy utilization. So these are the reference I have used for this preparation. So particularly I have taken more graphs from the oxygen stability of biodiesel, cause effects and prevention from fuel, the LC paper by author Narensh Kumar. And then all the tabulation I have taken from this biodiesel standard and testing materials. Any queries, sir?
Participants, if you have any clarification, you can interact with our speaker, Kannan. Any clarifications, sir?
Yeah, there is one question is why there is no commercialization in India. So the big trouble is yes, the cost, economic analysis, the economic analysis of biodiesel. So even the first one or two slide I mentioned that is the feedstock cost. Even if you take, even I did my PhD in waste cooking oil. If I collect the waste cooking oil, the cost is more. Even in India, we cannot find waste cooking oil. Even everywhere we go, and there is a first the waste cooking oil travel from the high five-star hotel to some other middle level hotel. Then it's go to the roadside vendors. We can't control it. Then we have to pay the money and we have to collect it. That's a big trouble. So once we take care of all those things, again the feedstock cost is more. Even if you go for the type of non-edible oils, it may affect indirectly affect the food behaviors, the food material, food cultivations. Okay, these are the big trouble. Again, the processing cost. Even if you develop the biodiesel, we need to go for different type of additives. Even the low temperature opportunity additives and the corrosive inhibitors, and the oxygen stability additives we need to add. So if you add it, the cost is more. That's why it is not viable in our country. But future we can see some different modifications. Yes, sir.
I think some of the participants have posted in the chat box, sir. Kannan, sir?
Yes, sir. Yes, sir. Yes, sir. I will check, sir.
Yeah.
So only the one person, the one faculty as well, there is only CTA number considered while choosing the fuel. Yeah, the CTA number, yes, sir. The CTA number is not. We are calculating only CTA index based on the initial boiling point and the middle boiling point and the end boiling point of the test samples. CTA number is purely calculated from different methodologies, sir. So we are approximating the CTA number.
Okay, Dr. Kannan, sir. Very good presentation.
Thank you, sir.
Very good presentation, and I think you have explained very neatly the standards and the instruments or devices used for finding the important properties during the fuel characterization for while developing new type of fuel, biofuel. Okay, so you also listed some of the implications of the various properties.
Yes, sir.
Thank you. Very nice presentation, and I think the participants already have posted in the chat box also. Very nice, sir. Thank you. Thank
Yes,
you
sir,
joining.
Yes,
Hello.
Yes, sir. Yes, sir. Yes, sir. There is one question from
Thank
Vivek.
thank you, sir. Thank you for sharing your expertise, sir. Thank you.
Okay.
And
Okay, sir. Okay, sir. I thank all participants for the passion, listening, and interaction, sir. Once again, I thank my sincere gratitude to co-convener and organizing secretary and coordinator, Mr. Dr. M. Sandrasekhar, sir. Thank you, sir. Thank you, Anna.
Kannan, sir, thank you.
Thank you, sir. Thank you, sir.
Kannan, sir, thank you. Kannan sir?
Sir, he's left, sir. MC, sir. Sir, Kannan sir was left, sir.
Hello. 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 Hello.
Hello?
Audible, sir. Audible.
Hearing, sir.
Sir, audible,
Audible,
sir.
sir. Audible. Yes, sir. Yes,
Okay,
sir.
okay. My presentation is visible, sir?
Yes, sir. Yes,
My
sir.
presentation is visible? Yes.
Yes, sir.
Okay.
Sir, Dr. Ganamati, sir.
Sir, good afternoon.
Shall we start, sir?
Yes, sir, we'll start.
Yeah. Thank you, sir. Thank you, sir.
Thank you.
It's not clear. So, good morning, participants. I welcome you after the break for the second session of day 2. For this session, we are having Dr. V. Jnanamurthy, assistant professor from Department of Mechanical Engineering, University College of Engineering, Viluppuram, a constant college of Anna University, Chennai. I welcome you, sir.
Thank you, sir. Welcome, sir.
So, Dr. V. Jnanamurthy did his ME in Automobile Engineering from MIT, Madras Institute of Technology, Anna University, Chennai, and obtained his PhD in the field of alternate fuels from MIT, Chennai. Jnanamurthy is working on ethanol-based fuels and numerically modeling of fluid flow, heat transfer, and combustion-related works. He has published more than 20 papers and having a very good record of H-index. He is also instrumental in developing all the laboratory facilities, state-of-art laboratory facilities. So right from the scratch, he has developed all laboratory facilities in the University College of Engineering, Viluppuram campus. So with this brief note, I request Dr. V. Jnanamurthy to take over the session. Sir, please, sir.
Oh, okay. Thank you, Professor. Your nice introductions. First of all, I thank our Vice Chancellor, our Registrar, and Dean, as well as the Dean of University College of Engineering, which campus, and the coordinators, and our beloved friend, Dr. Chandrasekharan sir, and Mahadevans, and who are all involved in this FDP program for successfully conducting such a program. I really thank each and everyone for giving this opportunity to share my views in the field of alcohol. It's a very interesting field as well as future generation to take over the field to contribute the society to the service. Really thank you, sir. Professor, visible my presentation, Professor?
Yes, sir. Yes, sir. Yes, sir. You have now presented,
Okay.
sir.
Okay, okay. Thank you, Professor. Thank you. Okay, alcohol is a very interesting fuel for IC engines for future generations. These two aspects we are discussed in the alternative of the fuels. One is that the greenhouse gas effect. Another one is called as depreciation of the fuels, and other so many aspects for the economic of the every countries for affecting the imported and exported things. Due to this concern, we are go for the alternative fuels. Once the fuel is there in the field, but we are I showing that here the fuel is for work for the fuel or work for the food. This is a very important things aspect. There are two ways. One is the renewable fuel and the non-renewable fuels. We are go for all the fuels are renewable. Once the renewable fuel, we are so far. What is our aspect? Our big objectives, either food and fuel. Why it means the population of the humans so on increases. This constraint we are affect the nature also. Depreciation of the fuel food also in the nature to how you are survival in the nature to with help of the farmers and grown up. But in this constraint, once that counter think fuel or food for the industries, but both the things we are achieved with the help of the society and to live in the nature to without affecting the natures. Okay, that alcohol is the very interesting fuel. The fuel means we know that the fuel is nothing but the carbon and hydrogen content, as well as some renewable fuel, oxygen is available. That type of fuel, you are using the burning, or we are taking the calories like that, or some carbohydrate like that by humans. But in our brain, we are also using the glucose as a fuel cells. Our brain is there. That fuel cells to send so many electrons to send the neural cells, and it will take the data. Just like the big data in our mind, big data is cloud computing in our mind, the fuels in our mind, everything in our human is there. Such a alcohol also our body is having some percentage of alcohol in our bodies. Okay, the alcohol is the organic compound that carries at least one hydroxyl functions. That is called as hydroxyl is the function the OH groups. These saturated carbons. The primary alcohol ethanol, ethyl alcohol are used for the drugs and main alcohol present alcoholic beverage. The general formula for alcohol CnH2n plus 1 and OH. The alcohol distillation possibly originated in the Indus Valley civilization before Christian values, 2000 years. The people of India used alcoholic drinks called sura. They made from fermented rice, barley, jaggery, and the flowers of mataka trees. This is the alcohol is generated from the initially our forefathers of our countries. That is this is the point. I talk about there are more concentrated in my field in ethanol. That's why I am concentrated on the ethanol as a alcohol fuel. The commonly called alcohol is called as ethyl alcohol. The drinks the alcohol for some perspectives. But when the principal type of alcohol found alcohol beverage to produce by the fermentation of the sugar in our India. It is a more volatile, flammable, and a colorless fuel. This fuel C2H5OH is using the alcohol, the fuel for 20th centuries. There are so many aspects they are using. But even though the alcohol initially used for since 1908, they are for the vehicles, as well as the alcohol not only in the vehicles or engine, so many other applications also you are using the alcohol. For example, the medicine solvents and flavorings and scents and cooking flames and other aspects for using the alcohol in the natures. The alcohol using why you are using the alcohol? It is a very clean, cheap, and renewables. That is the main theme of the alcohol. You are using even 21 centuries. Even though we are using the alcohol, the cost is very less. For example, in our alcohol, there are two types. One is called ethanol. There are two types. One is called as anhydrous ethanol and hydrous ethanol. The hydrous ethanol with the content of the water, anhydrous ethanol without water's content. Okay, when you are using the hydrous ethanol, we are called as a sprit. We are called as the sprit in sugar industries. The more of the thing, most of the things we are using it. For example, when anhydrous ethanol, we are using the fuel for particularly in our beloved Vajpayee government. They started the anhydrous ethanol using in the vehicle or E10 or up to E20. Their dreams for that on our Vajpayee government. But unfortunately, due to the politicals, they are not used. But still, you are using the 5% of ethanol in the petrol or 10% of ethanol in the petrol in India. The ethanol is a very clean and easy to utilize in the fuel for the IC engines. The ethanol, we are producing the ethanol from various aspects. Particularly in India, we are using the industry. Particularly, we are using the sugarcane industries more, and they are getting from the glucose. From the glucose, they converted the glucose into the ethanol with the help of the fermentation process. Okay, the top 5 ethanol production in 2010 or 2015, we are using the USA is the first top production around 16,270 billion liters per year. Next one is that Brazil, third one is that Europeans, and fourth one is the China and Canada and remaining other state countries. But the more ethanol production or alcohol production is USA using the now E85 or E90 fuels we are using it. India is only you are using the production of the ethanol 3 billion liters per year, but we are using also the gasoline industries. For example, we are using the E5 or E20 we are using in India, but in US and other countries we are using the E85, up to E85 they are using. There are so many problems with the help of the when you go for the uh, go for the IC engines, but there are so many aspects we are discussed in the later on our slides. But how the generation of the algorithm, how they will go further? They are using the first generation, second generation, and third generation nowadays. Now, the first generation, we are based on the starch-based fuels. We are using the cereal starch, the corn, USA and China. We are using rice for some other country. You are using barley and Europe using, and wheat. You are using the Russia and Europe. But root starch, you are using the some root potato like that. You are using the South Asia and other countries. The sugar-based things, initially we are using the Brazil, then best sugar using the Europe, and sweet sugar using India. Okay, this aspect we are go for the first generation. Second generation in modern days, particularly in the 21st centuries, and we are using the third generation and the second generation from the lignocellulose based concept and algae-based ethanol productions. Okay, this ethanol production, particularly in the algae-based for both the biodiesel as well as the bioethanol production is possible in the algae. Particularly, algae is developed in day-to-day concept to using so many area for concentrated algae productions. What is the advantages and the disadvantages to concentrate on the ethanol things? First one is that the clean and burn fuel. The ethanol is a very clean fuel to burn it. The very less greenhouse gas productions. Why means it is a renewable fuel. It is very less greenhouse gas, particularly in the CO2 production, carbon dioxide production. The positive energy balance, depending on the type of raw stock we are using it, we are using. Any plants, we are, for example, bioethanol production is possible in modern second generation and third generation. Any plantation, you have some sugar glucose, that from the glucose to find out that they get the ethanol from there. Then it is a carbon natural. It will be recycling of the CO2 production. It will be very easier. Decrease the ozone. It is renewable and energy security. So reduce the amount of high volatile factors and more easily biodegradable and non-toxic these things. This is the advantage we are so far we are using the ethanols. Then we are what is the disadvantage? These are main things. The carbon dioxide. For example, when the production of the ethanol or methanol, the more carbon dioxide is produced, and it is a debate of that either you are using the fuel or food. What aspect you are thinking? That is another very important. Compared to the petroleum, is a very less efficiency and cannot be used existing engine. That is very difficult to use in the existing engine. As well as the cold start is difficult, and the transportation and other things is some disadvantages. These disadvantages to overcome to use as a fuels. So how the ethanol is productions? Either ethanol production in particularly in India, the fermentation process, fermentation process, with the help of the fermentation, we are getting from the sugar cane, then sugar cane milling, then fermentations, and the way to get from all aspect of the neat alcohol, then anhydrous alcohols. Some Europe and US or China, they are using the biomass or some corn and wheat, they are using it to getting the process. Even though we are using more amount of CO2 production, that CO2 to carrying the quick for a beverage unit or quick cooling needs and refrigeration and other aspect we are using it. So what is the main aspect to change over the alcohol fuel? We are particularly the global warming, climate changes, crisis about every crisis. Already I discussed. It is a renewable point of view. The alcohol is an attractive fuel for both the gasoline as well as diesel engine in modern days. The alcohol, particularly the methanol, ethanol, propanol, and the butanol, widely used as a fuel. It can be synthesized by chemically or biologically. When obtained from the biological materials or biological process, they are known as bioalcohols. There is no chemical difference between the biologically produced or chemically produced alcohol. They have the characters which allow them to use internal combustion engine and the general chemical formula C2H5OH. It's a very important thing when you are alcohol fuel. We have discussed the property of the fuel is very important. Once your property to understand very well, once your property or what is the property to take over, what the property, how it will be affect the combustion and the emission aspect. This is very important to take over in the alcohol. Particularly in the chemical formula, you should understand what is the carbon, hydrogen, and the oxygen present. That is very important. But particularly in the bioalcohol, the renewable fuel, it will be both the carbon, hydrogen, and oxygen. But the hydrogen is constant, only the carbon and the oxygen is varying. If you the oxygen percentage increases, the carbon percentage is decreases. That is very important aspect. You are keeping your mind when your chemical formula is also very important. What is the carbon available? What is the oxygen available? What is the hydrogen available? All the renewable fuel, the hydrogen is almost 12 to 30. But when the remaining, the carbon is, for example, when the fossil fuel, the petroleum or diesel, the hydrogen is 12 to 17. The carbon is 86 to 83. But when you go for the oxygen, there is no oxygen in the fossil fuels. But when they go for the renewable fuel, the oxygen is also available. At that time, you should understand that the oxygen is a very important to initiate the combustion or complete combustion is happening. But only thing, the oxygen is not loosely bonded. It will be very tight bonding. That is very important. The oxygen cannot be easy to get in from the fuel, or oxidation is not possible. That is depend on the fuel. It will be varying the bonding structure of the oxygens. Particularly in the ethanol, the oxygen bonding is very effective. The high bonding structure, only high temperature, only the oxygen is reacted or burning is effectively to place, particularly in the ethanol. That's why when you are using the ethanol, the carbon and the hydrogen and the oxygen is very important. Once the hydrogen cannot be much more variation in any fuel, almost closer variation, but only the carbon and the oxygen is variations. So once the carbon values decreases, the oxygen value increases. The oxygen value decreases, the carbon values increases. Like that, it will be changes, it will be happens. Another very important thing, the cetane number. Particularly when you are using the ethanol, the research octane values is higher. That's why the research octane number is around 106, but the research cetane number is 5 to 8. That's why it is not suitable for the diesel engine, but only the suitable for the petrol engine. But initially they expected. But now you change over the two aspects. One is that when any engine, the two aspects is very important. One is that modify the engine according to the fuel. One is that modify the engine according to the fuel. Another one is another one way to modify the fuel according to the engine. That is two aspects is very important. One is that modify the engine according to the fuel. Another one aspect is modify the engine according to the fuel. Once either you are modify the engine, you can according to the fuel. Modify the fuel according to the engine. That is the two aspect is very important. But when you are using the ethanol, both the things is very important. Both the modify the engine as well as the modify the fuel. When you are go for the higher amount of ethanol you are using. So another values is very important, the heating values. Particularly in the diesel and the petrol, they are around 46 megajoule. But you can go for the ethanol around 26. When you go for the methanol around 20. That is also very important. So another very important, the auto-ignition temperature. For example, when you are go for the SA engine or CA engine, the SA engine means spark ignition engine, the CA engine means compression ignition engine. But when the auto ignition temperature is diesel is very lower, that's why you go for the auto ignition. Due to the compression, it will be ignited. But in the petrol, the auto ignition temperature is higher. It is not possible to auto ignite. That's why you are with the help of the spark plug to ignite the fuel. That's why it is called as spark ignition. That is auto ignition temperature also very important. So another very important, the latent heat of vaporizations. The how much of energy required to heat. For example, we are think that in thermodynamics we are specific heat and specific heat constant volume. The specific heat means amount of energy or heat required to rise 1 degree or 5 degree. That is a specific heat. Same things when you go for the latent heat also very important. What is the latent heat values? So another very important, flame speed, flame or flame velocity, that also very important. You are reducing the quenching distance. When the flame speed is higher, particularly we are using the hydrogen is a higher flame speed. For example, ethanol also higher flame speed. But when the diesel is lower flame speed. For example, when the biodiesel is very lower flame speed. But when the flame speed is increases, the flame velocity is increases. Once the flame velocity increases, you are reducing the quenching distance. Once you are reducing the quenching distance, you are reducing the unbound hydrocarbons. That also very important. So various aspects we are discussed here. Not only I am putting the single property, there are so many paper I taken from that. The values of that, not only the individual properties, all the properties are very important. Particularly Flashpoint, last session discussed all the properties. I won't again go further. Particularly I discussed here particularly what is the necessity of the things. So another is very important, the density. The density is very important when you go for the fuel to less density, it will be very easy to replace. For example, when the combustion aspect, we discussed that how you are dispersing your fuels. Particularly if your density is lower, what happens? The droplet size maybe decreases. Once the droplet size is decreases, the fine droplet increasing surface area. That is also very important. Once the droplet size is more, what happens? The surface area is higher. Once the surface area is higher, easy to vaporize, you are reducing the physical and the chemical delay. That is also very important. When you are think that the density is a very key point. Also, the viscosity also very important. Once the viscosity of the fuel is decreases, what will be happen? For example, the droplet size of the injector will be decreases. Once the droplet size decreases, what happens? The more surface area you are getting for the particular volume basis or mass basis. That also very important. So another aspect, the octane number. For a octane number for a spark ignition engine, quality of the fuels. For a cetane number, it's a quality of fuel for the diesel engines. But both the things not suitable for octane fuel for the diesel or cetane fuel for the petrol. But each one having the best quality for particular engines. That is also very important. So another very important for using the methanol as a fuel, it's a high heat of evaporation. That is very important. Once the latent heater is higher, the vaporization rate is higher. Once the vaporization is higher, the physical delay of the system is decreases. Once the physical delay is decreases, the combustion duration is increases. That is very important. The higher latent heat, your more amount of combustion durations. That is very important. You are reducing the physical delays. So another is very important, low stoichiometric gas fuel ratio. Why you are a low stoichiometric gas fuel ratio? The fuel itself, oxygen is there. That's why no need much more oxygen availabilities. That's why the low stoichiometric ratio, particularly for the ethanol, your stoichiometric ratio is 9:1. There are two ways your stoichiometric ratio. One is that mass basis, another one is called as volume basis. You can think that the mass basis and the volume basis is very important. Once the stoichiometric gas fuel ratio, think that the gasoline, for example, 14.7, and methanol is 6.7, and ethanol is 9. This is a mass basis. If you the volume basis, it will be increases. Keep it in your mind. The 14.7 is that it is the mass basis, not for the volume basis. Very important. So another very important when you are discuss the surface tension, also very important. What is the surface tension? If the surface tension is decreases and decreases, what will be the more effect? Your droplet size may be decreases. That also very important. And other things are already discussed in the last session. I won't go for much more in the physical properties. But when you are any fuel, you are more confident on the physical property, then only you are well known on the combustion aspect. We don't know the physical property properly, we cannot discuss the combustion or emission aspect. Once you are go through the physical properties correct manner, that physical property, what will be the, it will be the betterment of the combustion or not betterment of the combustion, you should understand. It will be betterment of the emission or reduce the emission or increase the emission, you should understand based on the property of the fuels. That is that's why I am telling that your design, modify the fuel according to the engine. Now your existing engine is designed for the petrol or designed for the diesel, not for the designed for biodiesel or ethanol or methanol or whatever it is. The existing engine is designed for fuel, petrol and diesel. The particular engine is designed for the petrol and diesel, not for the ethanol and other biofuels. It is only designed suitable for that petrol engine as well as diesel engine. Keep it in your mind. When you are go for the using the existing engine, you should modify the engine or as well as modify the fuel. Once you modify the fuel means you are changing the physical characteristics according to the engine design. For example, I can go for the petrol engine. You can modify the physical property of the fuel according to the petrol engine. Modify the physical property of the fuel according to the diesel engine. That's why is now the designed for example, optimum design is only for the diesel and petrol engine, not for the other fuels. That's why you should understand that fuel properties well understand. You should modify the fuel properties according to the engine or modify the engine according to the fuel properties. That is the two aspect is very important. You should understand the physical property of the fuel. So another very important, you are go for that fuel property. The particularly ethanol or methanol, it is a lower boiling point. That lower boiling point means easy to quenching is very easier. To absorb the heat is very easier. That's why it will be more easy to vaporize very faster and quicker. That's why it will be reducing the physical delay as well as the lean burn engine is possible. What is the lean burn engine? Lean burn engine means we are having the stoichiometric mixture. That's below the stoichiometric mixture we are called as a rich mixture. Above the stoichiometric mixture we are called as a lean mixture. But when you go for the diesel engine, always running on the lean mixture. When you go for the petrol engine, always running on the rich mixture. Keep it in your mind. Why means in the petrol engine, It is a homogeneous mixture. In the diesel engine, they are called as heterogeneous mixture. That's why we are think that it is very important what aspect you are think. Either property of the engine is very important. Also, I mentioned here the methanol having more amount of 40, around 50% of the oxygen percentage in the weight basis. If you, the 50% is oxygen is there in methanol, remaining 13% for that hydrogen, and only the around 37 percentage only the carbon is there. Keep it in your mind. Same in ethanol, 34 percentage oxygen and 13 percentage in hydrogen, and remaining only carbon is around 30 to 34 percentage. Okay, according like that, you should understand the physical property. You should easy to elaborate the combustion and the emission aspect, as well as you can modify the engines. So another very important things, these are the things I think already I discussed. The most of the ethanol production is United States, and other than now our China is ethanol production rate maybe after 5 years maybe in almost closer to the US or overcome the US maybe in China. The more amount of bioethanol production is carried out. Now the up to 2019, there are almost now the latest data to the world fossil production is country around 299 million liters produced by the USA. Next one is that 163 Brazil, and Europe around 27, and remaining rest of the country is very less. The more contribution is now the US and the Brazil is in the particularly ethanol and the productions. Now so another very important in this property, the mixtures. For example, if you the values are very important. Already I told you when the research level, the specific heat CP and CV value here, you can see that the gasoline around the index is not applicable. Even the around 1.3, the polytropic index is there. The methanol and ethanol, we are using that the CP/CV value is almost 1.38 or 1. These values, when you go for the chemical kinetics, particularly I tell you what is the chemical kinetic in the later session, later slides. But the chemical kinetics, when you go for that, the very important the CP values and the other flammability limits and other energy content level, everything is very important. You are when you go for that fine combustion analysis, each and every physical properties are very dominated by the fine combustion samples. So another is very important. The aspect we go for the methanol. The methanol is the short chain alcohol that can be produced from both renewable as well as fossil feedstock. The most of the methanol production in India, the coal, and now we go for that agriculture waste or farmer waste. We are producing methanol is possible. The methanol has a chemical formula CH3OH, and it is a higher hydrocarbon ratio according to the fuel. Besides, the methanol has a high oxygen content, high octane number like ethanol. It is a high oxygen content, provide better combustions. This is the methanol production. The methanol is produced in the form of so many industries produce, particularly in biomethanol produced in Chennai, Coimbatore market, the wasted vegetables and other things. We are producing the methanol plant is there in our Coimbatore market here. Okay, this is the coal gasifications. This is very important to producing the methanol. So coal, why how you are coal production? The gasification and the distillation process to get the methanol. So methanol, we have the molecular weight is 32 and the carbon is around 37. The hydrogen is 12.5 and the oxygen is 50. You can think that this is a very important properties of methanol to this fuel, to how you are control it, how you are replace the IC engine is very important. The auto ignition temperature is also higher for the methanols. Alcohol in the diesel engine, there are some techniques we are using alcohol when using the diesel engine. One is called as dual fuel injection. Second one is called as surface ignition alcohol. Third one is called as alcohol diesel emulsion. Fourth one is called as alcohol fumigation, and spark of the ignition of the alcohol or flow plug. We don't think that spark. Instead of the spark, we are using the flow plugs. Then alcohol containing ignition improver attitudes. These are all the techniques. They are using the higher amount of alcohol using existing diesel engine. Both the modify the engine as well as existing engine. These are the techniques we are using here. One is called as dual fuel engine. Dual fuel engine means diesel act as an igniter. Igniter means just like a spark plug, but you are using the inlet manifold to supply the alcohol or inject the alcohol to the inlet manifold, or two injection. One injection for the methanol, one injection for the diesel. The methanol is injected on the either end of the suction stroke or beginning of the compression stroke, or beginning of the suction stroke. According to that, we are using the dual fuel with one is that inlet manifold, another one is called as injector. The injector always diesel is the injector. This diesel acts as an igniter. Why means the methanol having higher auto-ignition temperature, it will not possible to self-ignited. Once you self-ignited, you are increasing the compression ratio above the compression ratio around 25:1. Then only possible. Even though if you are 25:1, the knocking is to affect the combustion chamber. To avoid that, you will go for the diesel as a small amount to participate as an igniter, just like as a spark plug. To initiate the combustion. Once the initiation of the combustion, after that burning is possible. This type of technique we are called as the dual fuel engines. So another is called as ignition improvers. For example, we are using the diethyl carbonate, diethyl glycol, or some ignition improver. Why means the ethanol or methanol having the lower cetane number. Once that the lower cetane number is not possible to ignite the self-ignition characters. Once you are improve the fuel qualities to adding the cetane improvers. Or cetane improver is very important for alcohol fuel. Diethyl ether or diethyl ether is around 200 for the cetane number. To increasing the cetane number, some amount of diethyl ether to mix with the methanol or ethanol, it will act as a good CA engine fuels. So another one is called as emulsifiers. The diesel and the ethanol cannot be easy to mix. It will not mix properly. Both the visually or both the different carbon and hydrogen atoms, the molecules are not in the same molecules. That's why it will not possible to mix with the diesel and the alcohol. So this technique we are called as the emulsifier. We are called as another name is called as blending techniques. The blending means to mix with the alcohol fuel with the ethanol or methanol. Okay, this emulsifier is very important, or we are called as a surfactants. We are called as the surfactant is very important to mix with the binding of the methanol and the ethanol. This we are called as a surfactant. That surfactant to add in the fuel ethanol or methanol to mix with the fuel and the diesel and the ethanol. We are using the surfactant. We are called as diethyl carbonate or ethyl acetate. We are using it in my research work. You will see later on. Okay, another this directly we are single injector. The mixing of the fuels into the diesel injection we are called as a emulsifier or blending techniques. This is the for example this is the diesel, this is the ethanol. It will be not mixed with two things. With help of the agent, some surfactant. For example, we are using the some oil in our hand. We are using the washing with mixing with the water. We are using the soap. Okay, the soap is purpose of that. You are surfactants. You are removing the oil from your hand. Okay, same way you are using the surfactant mixed with the diesel and ethanol mixture, it will be phase separation is reduces. That's why we are using the emulsification. So another technique we are called as emulsification. They are almost closer to that. Always closer to that engine. Emulsifier is also dual fuel system. It is to emulsify with the help of the additives or some surfactant you are using it already. This technique already you are using. So another technique we are called as a fumigation techniques. This fumigation technique we are called as a dual fuel technique. We are using the inlet port or we are using the help of the carburetor. You are fumigate just like the petrol fumigations. Okay, that petrol is fumigated with the inlet. Same way you are sending the ethanol or methanol to the engine. The fuel in the for example, diesel acts as a igniter. We are using it. So another technique we are using is a surface ignition techniques. For example, we are using the flow plugs. Now modern days we are using the not only the flow plug, we are using the spark plug and the other ignition techniques also there. But the surface ignition means the fuel is same like the petrol engine, but the ignition is occur with the help of the ignition systems. Okay, this is the surface ignition techniques. Here we have the some electrical winding, the electrical heater to ignite the fuel. Why means it will be higher auto ignition temperature. That's why we are ignite the fuel. Is very important. So, what is the comparative study of alcohol and biodiesel? Or the methanol and ethanol is a very important. The higher cooling, hence less compression works, high latent heat of vaporization, high structure gas fuel ratio, high oxygen content, and reduce the soot and smoke formations. But in the same way, in the ethanol also, it is a renewable source, produce the less carbon and soot carbon monoxide. Okay. The disadvantages of the fuel ethanol or methanol, the poor combustion characteristics, lower energy content, longer ignition delay, and more corrosive and lower flash time. Yes, particularly in the ethanol or methanol, it will be very high corrosive nature of the materials. It will be affecting the life of the duration of the materials or life of the system. To avoid that, now we are going for the thermal barrier coating like that. There are so many coating techniques are using it. We will see that later. And this is the another. I don't go for the butanol and other things. I only concentrate on the ethanol. Okay, I giving the two aspects. Any fuel, one is the performance aspect, another one is the combustion aspect, third one is the emission aspect. These three things are very important. One is the performance. Performance means you are based on the specific fuel consumption and the brake thermal efficiency. Combustion aspect means your cylinder pressure, heat release rate, mass fraction burn. These three things are very important. One is the performance aspect, specific fuel consumption, and the brake thermal efficiency. Second one is the combustion aspect, the heat release rate, cylinder pressure, and the mass fraction burn. Third one is called as emission aspect. You are go for that carbon monoxide, unburned hydrocarbon, and oxides of nitrogen, and smoke or particulate emissions. These three things are very important. Based on the literature survey, you can give the things how the methanol you are using. For example, the same ethanol you are using that 5% and 10% and 15%. The single cylinder diesel engine, the brake specific fuel consumption is increases, NOx emission is decreases, and the hydrocarbon CO. The specific fuel consumption is very important. This is the vice versa of the brake thermal efficiency. If the brake thermal efficiency is higher, the specific fuel consumption is lower. There are two aspects. One is that brake specific fuel consumption. Only single fuel you are using it, you are called as a brake specific fuel consumption. If you using the two fuel at a time, for example, emulsification or blending, don't use the brake specific fuel consumption. There you are using the brake specific energy consumption. Don't only your single fuel you are using, you are called as brake specific fuel consumption. If you more than one fuel you are using, you are called as brake specific energy consumption. That is very important. Keep it in your minds. So another aspect, when the brake thermal efficiency is higher, the brake specific fuel consumption is decreases. The vice versa. Once the efficiency increases, fuel consumption is decreases. That is easy to understand. So another very important, when the combustion aspect, for example, the cylinder pressure. For example, when you are using the SA engine, the cylinder pressure is now modern engine is 40 to 60 the bar pressures. For example, if you go for the diesel engine, around 70 to around 90 bar, and nowadays you are up to 120 bar pressure is going on. Okay, but even though you have high pressure, you are increasing the performance of the cylinder, as well as the peak pressure always closer to the TDC. That is very important. Then only the heat energy converted to the mechanical energy. The peak pressure always closer to the TDC, or 5 to 10 degree TDC. It will be a higher peak pressure. The more amount of chemical energy converted to the heat energy, then heat energy converted to the mechanical energy is possible. Keep in your minds. So as well as the heat release rate is another is very important. The heat release rate is, for example, the ignition delay is particularly in the petrol engine and diesel engine. Petrol engine is called as premixed combustion. Petrol engine we are called as the premixed combustion. The diesel engine we are called as two aspects. One is called as premixed combustion. Another one is called as diffusion combustion. If you for example, in the diesel engine, the premixed combustion is almost less. The diffusion combustion is higher. But when you go for the alcohol as a fuel, you are increasing the premixed combustion, decrease the diffusion combustion. Why? Means the higher latent heat of appreciation. Due to the higher latent heat of appreciation, the premixed combustion is higher, the diffusion combustion is lower. To avoid these things, you are changing the engine modifications. So another important mass fraction burns. The mass fraction burn also very important. The 95% mass fraction burn or 100%, what angle the mass fraction is burning is happening. That is called as Weber's constant is very important, mass fraction burn. What is called as Weber's constant. That is also very important to calculate the mass fraction burn. So another very important, third one is called as emission aspect. Emission is very important. Fourth emission, particularly in the diesel engine, one is called as carbon monoxide. The carbon monoxide emission is, mainly the CO emission is insufficient of oxygen. The insufficient of oxygen is main focus for the CO emissions. You can petrol or when you go for the ethanol or methanol, the fuel itself, it will be a higher amount of oxygen. To avoid the carbon monoxide emission, we are using the ethanol or alcohol fuels. Okay, the second one is called as nitrous oxide or oxides of nitrogen. We are called as oxides of nitrogen. The oxides of nitrogen, two aspects. One is called as thermal NOx, and another one is called as prompt NOx. The thermal NOx based on that Jelodovich mechanism. What is called as Jelodovich mechanism? Jelodovich mechanism means it is called due to the high temperature, the oxygen and the nitrogen react with the oxygen. The nitrogen react with the oxygen to formation of the nitrous oxide or oxides of nitrogen, NO, NO2, NO3, NO4, like that. We are called as NOx. So third one is called as smoke emission or particulate emission. The smoke emission is mainly causes of pyrolysis effect. Keep it in your mind. The smoke emission mainly causes of the pyrolysis effect. That pyrolysis effect means the absence of oxygen at high temperature to formation of smoke. The absence of oxygen at high temperature, the carbon is suppress the oxidation to formation of the carbons, the unburned carbon. That carbon we are called as what is called as smoke or particulate emissions. That is called as the smoke formation is mainly causes of pyrolysis effect. Third one is called as CO2 emission. Now the CO2 emission, everybody know that it is called as a greenhouse gas. The renewable fuel of alcohol, the CO2 emission is cyclic process. You are reducing the CO2 emission. So another, this is the emission aspect when you go for. Okay, now you can see here, everyone they discuss up to 20% maximum of methanol you are using the 30% up to now this latest research paper, particularly in the 2020 paper, they using it. So another ethanol aspect, when you go for the ethanol aspect, for example, E5 to E15, some of the, I am using nanomurti ATAL. You can see here, this is a 68. My paper, Kirloskar, I am using up to E70, but here my paper also identified here. Why I am telling that? When you go for that ethanol as a paper, we are using that E30. Some papers, the specific fuel consumption is decreases. Some paper, the specific fuel consumption is increases. Based on the engine design as well as fuel quality to varying that. But generally, the CO emission is decreases when you are go for the alcohol fuels. The hydrocarbon emission, some papers increases, some paper is decreases. Generally, the hydrocarbon emission is decreases, increases. Why means the alcohol fuel low boiling points. That's why higher vaporization. That's why the quenching density also, even though decreases, the fuel will go for the end of the cylinder. That's why it will be higher possible. The hydrocarbon emission is possible more, particularly in the alcohol fuels. So another very important, the ethyl mizol ether, they are using the E25 and other things. So another very important, when you go for the ethanol in modern days, we are using the click ether up to ethanol 75% in the spark ignition engine. Not for the diesel engine. This is all the things, the higher proportion of ethanol you are using in the what? Spark ignition engine. That's why it means the octane number is higher for the ethanol or methanol or alcohol fuel. That is highly suitable for the petrol engine. That's why they are using even 100, E10, E100 also you are using it. But diesel engine, only we are using the E25. Myself, only you are using the E70 up to, you can later slide, you can see that. Okay, another very important, this is a very important graph for the emission aspect as well as the performance aspect. This is called as smoke formations. This is called as NOx formation. Okay, this area we are called as a NOx formation curve. This area we are called as smoke formation. When you are go for the diesel, this is called as a diesel, is a higher smoke formation. Why means the pyrolysis effect, the absence of oxygen and the high temperature, more amount of smoke is possible in the diesel engine. When you go for the methanol or ethanol, only the small amount of the smoke formation when you go for that. So another is very important, when the laminar flames, when the laminar flame, the flame speed is either laminar or turbulence. When you go for the laminar means the inertia, the flames laminar or based on the laminar or turbulent, based on the Reynolds number. The Reynolds number we are called as the inertial force by viscous force. Particularly in the gaseous state, it will be laminar or flame is higher in the ethanol. That's why we are go for it. So another is very important. When you go for the ethanol or methanol, there are two ways you are discussed that. One is the experimental aspect, another one is the simulation aspect. When the experimental aspect, we are changing the fuel property or modify the engine operating parameter like that. But when the simulation is very important, to discuss the simulation with the help of the chemical kinetics. The software you are using that, the chemical kinetics, particularly for that kinetics of the fuel. For example, we all know that the product and the final product, we know that CO2 for complete combustion means only we are getting the water and the CO2. When we go for the incomplete combustion means the product we are getting only for that incomplete combustion CO, HC, unbound hydrocarbon and the NOx and the smoke emission. One more thing I don't discuss with the unbound hydrocarbon. The unbound hydrocarbon only possible of that quenching, higher quenching area, the unbound hydrocarbon is possible. Another way the unbound hydrocarbon is possible for the crevice effect. There are two effects the unbound hydrocarbon is forming. One is called as quenching, so another one is called as crevice. This is possible in the unbound hydrocarbon. Okay, now we know that in between reactions, we have discussed that in between reaction, what are the, for example, shown lakhs of reaction is possible for the chemical kinetics. Chemical kinetics means what is the radicals formation in the engines, fuels. Radical, what are the radical formation in the fuels? If the radical is formation is very faster, what will be happen? The higher efficiency and less emission is possible. Therefore, we should understand that chemical kinetics of the fuel is very important. As well as in modern days, we are using the help of the flow visualization techniques. We are called as flow visualization technique. With the help of the combustion chamber, easy to visualize. For example, transparent combustion chamber, you have a higher camera speed. With the help of the higher camera speed, where the combustion is happened, how the flow of the combustion, we are discussed there. Okay, these are the things we are with the help of the simulation. For example, we are single zone model, two zone model, or multi zone models. With the help of the single zone model means we are using the first law of thermodynamics, two zone model and unburned zone and burnt zone, like that we are discussed. But I am discussed not much more in the simulation. Why means my aspect is theoretical, experimental aspect. I am discussed more. But this one is this engine we are called as a spark ignition engine. Here, when you are a complete combustion, there is no much more knocking happens. But here, the knocking due to the combustion is more amount of knocking to this avoid the engine failures after some operations. So another very important, the heat release rate of the combustion phase. The heat release rate also very important. It will be closer to the heat release rate to the TDC, the higher amount of heat energy converted to the mechanical energy. That is that's why we are go for the methanol, ethanol. It will be heat release rate is closer to the TDC. That's why I am telling that it is a pre-mixed combustion. The much less diffusion combustion for the compared to the diesel engine. So another is fuel consumption is very important. We are also what is the fuel consumption rate? For example, if you are using the methanol, ethanol, the fuel consumption is higher compared to the diesel and the petrol. Why means it will be lower heating values. That's why more amount of fuel is consumed for the alcohol fuels. So another aspect I don't discuss much more. Okay, much more. Why means here based on the literature survey, their methanol or ethanol you are using. What is the cylinder pressure, heat release rate, exhaust gas temperature, CO, NOx, and hydrocarbon emission, and smoke, and other aspect we have discussed that. But how it will be vary? They are depend on the fuel aspect, depend on the engine operating variables. This also I take small things. For example, when you go for the fuel, biodiesel, ethanol, for example, the exhaust gas temperature, some finder reducing the exhaust gas temperature, some finder you are increasing the exhaust gas temperature, some finder increase the heat release rate, all the finders are increase the heat release rate. Why means the higher latent heat of vaporization, maybe any ethanol fuel or methanol fuel, higher heat release rate compared to the existing diesel or petrols. For example, some papers you are reducing the cylinder pressure, some fuel you are increasing the cylinder pressure, depend on your operating parameters you are using it. Okay, another aspect I can discuss here, when you goes for the methanol or methanol SI engine, what is the values of this higher or lower? They are literature surveys. Okay, I go for the methanol aspect. What is the properties or alcohol properties, higher burning velocity, oxygen is higher, and carbon to carbon bonding is very lower, and high hydrocarbon ratios and molecular expansion. These are all the things I can discuss. You can share it. I will share the slide. Later on, you can see the each and every aspect. Okay, so very important when you are the researcher. What is the previous studies? When you are go for the initial start of the researcher, so very important. What is the previous studies? You can go through the literature. What are the things they are doing in the existing? They are up to 2020. So many researchers, so many aspects. They are find out the things. Next, you can find out what is the research gap. That is very important. When you go for the ethanol or alcohol fuel, there are so much of research gap is there. Final slide, I will tell you what are the research gap in the ethanol and the methanols. So another very important, we are using the alcohol fuel. We are called as a flexible fuel vehicle, or another name we are called as that homogeneous charge compression ignition engines. There are two things: either flexible fuel vehicle or homogeneous charge compression ignition vehicle. Okay, the HCI engine means the marriage of CI and the SA engine. Simply, my professor told that what is meant by HCI engine? The marriage of CI and the SA engine. The homogeneous charge with the help of the compression ignition engine, not for the SA engine, spark ignition engine. The homogeneous mixture ignite with the help of the compression ignition. That's why we are called as a flexible fuel vehicles. Okay, when you are go for the flexible fuel vehicle, both the methanol and the ethanol, the flame speed is closer to the diesel. Okay, that type of things happen in your slides. So another is very important. I already tell you, in modern vehicles, electronic engine management system. For example, in olden engine, we are using the conventional engine. They are not much more electronics. Now modern, all the vehicle, we are using the electronic injection fuels. That means, for example, in the diesel engine, around 2,500 bar fuel is injected. For example, even gasoline direct injection system, 200 bar injection pressures. If you go for the petrol engine, gasoline direct injection is 200 bar. If you go for the gasoline, common rail direct injection system, around 2,500 bar. What is the difference? For example, if you gasoline direct injection system, the fuel is injected on the beginning of the section or end of the section or beginning of the compressions. But in the common rail direct injection system, always closer to the TDC, before the 5 degree or 10 degree TDC, or we are go for that higher injection pressure around 2,500 bar. That's why the common rail direct injection system, the fuel is injected on the end of the compression stroke. That is keep it in your mind. But gasoline direct injection system, your fuel is injected on the beginning of the compression. But in the electronic injection system, now modern days, you go for the split injection system also possible. The split injection means the main injection, before injection, after injection. For example, pre-injection, post-injection. That's why we are nowadays we are go for the split injection system is possible in the modern alcohol vehicles. The modern alcohol vehicle, where some of the fuel is injected on the before beginning of the section, some of the fuel is injected on the end of the section and the end of the compression. Some of the fuel is injected on the post-injection. Generally, the post-injection is now the emission norm standard is very crucial. Particularly, we are using the Euro 6 norm to reduce the NOx emission or reduce the smoke emission. For the emission reduction, to giving the penalty of the fuel. Very keep it in your mind. Not for the performance and emission. The fuel is penalty of the fuel given to the emission standard. That's why modern days we are go for the post injections. That also we are go through it. Now the flow plug also we are using it on the electronic control system, throttle position sensor, fuel pump, and all the things we are you are using the flexible fuel vehicle to control it. So another things, I can go for my research up to these things, just to overview of the alcohol fuel engines. My research is to study the performance emission characteristics of the ethanol, the high proportion of ethanol in the CA engines. Okay, what are the method I am using here? There are 4 methods I can use in that. Method 1 is without engine modification, I can using the ethanol blend with diesel with help of the emulsifier, that are surfactant. That surfactant we are called as ethyl acetate or diethyl carbonate. I am using it without modify the engine. Up to 40% of ethanol you are using it. Only the good efficiency for the E20s. Second method, I can go for the proportion of the ethanol used, modify the engine operating parameter with help of the Taguchi gradation analysis, modify the some engine operating parameter, particularly the compression ratio, intake temperature, intake pressure, and injection timing and the injection pressure. Like that, they modify the engine operating parameter. I can go for that E50. Ethanol 50% mixed with the diesels. So another third method, I can go for the proportion of the ethanol used engine modified with thermal barrier coating. Modified engine operating parameter with thermal barrier coating, and there's some bowl chamber, changing the some bowl modification. Up to E50, I can use it in our research lab. Fourth method, the proportion of ethanol used up to 70% of ethanol is possible. Modify the engine operating parameter. This operating parameter I can fix it with help of the dual fuel mode. We are go for that E70 is possible. This is the method I can use in the thermal barrier coatings. Okay, now already I can discuss how you are, for example, when you are blending the ethanol, diesel, this is the separation is possible. After I can using the surfactant, the ethanol or methanol blended with the naturally with the diesel. We are called as using the surfactant, we are called as ethyl acetate 2% or diethyl carbonate 2%. Finally, I can find out. Also, I can get the pattern from our Indian governments. So this is our engine experimental setup. This is our engine specification. This is our lab facility available at University College of Engineering, Vilupuram. This is I can change the modification. You can see here, this is the injector. I can dual fuel injector. This is the temperature. This is the sensor we are using that. As well as I can using the heater, fuel heater and the intake heater exergy technique also I am using it. Here, the counterflow technique, we are heated the exhaust gas, wasted exhaust gas, you can recover the heat from the inlet manifold. These are all the things. I can using the injector. For example, this is the injector. This is the when the injection is happen. This is the slide you are using. This area only the injection is possible. Remaining time there is no injection is happens. Okay, like that I can design the injector for the manifold injection as well as the injection design. We have the good facility for the combustion analysis and the emission test with the help of the 4-gas analyzer, with the help of the Apex software, with the help of the National Instrument software to analyze the combustion analysis. This is called as a 4-gas, 5-gas analyzer. This is the smoke meter we are using it. Okay, first method I can using the application of ethanol up to 30% of the CA engine without engine modification. Then this performance is getting almost higher than the diesel. Why means the diesel compared to the ethanol higher efficiency without up to 20% is good. There is no modification required. The cylinder pressure also it will be very closer to the diesel, as well as the combustion duration is higher. Particularly up to 20% ethanol we are using it. The combustion duration is higher. That's why we are using in that. This is the cylinder pressure curve. This is the heat release curve. I already told you that compared to the diesel, the higher heat release rate. Why means the ethanol having higher latent heat of vaporization. That's why it will take longer time for ignition. The physical delay and chemical delay take longer time. Once the fuel is accumulated or accumulated, that accumulated fuel suddenly to burning is happened. That's why the accumulation of the fuel is higher heat release rate is happen in the alcohol fuel. Keep it in your mind. Always the heat release rate is higher compared to the petrol and the diesel. So another aspect I already discussed, the carbon monoxide emission is lower compared to the petrol and diesel, compared to the diesel. Why means the carbon monoxide is emission is formation only the absence of oxygen. But in the fuel itself, the ethanol higher oxygen availability, the more amount of oxygen, that oxygen particularly in the ethanol, it will not used in the lower load, only higher load, only the oxygen bonding is liberated. The oxygen bonding is liberated only the high temperature. That's only the higher load, only the carbon monoxide emission is lower. You keep it in your mind. When the lower load, the oxygen bonding is structure cannot be blast. Only the higher temperature, only the oxygen bond is blast. That's when they replace the oxygen content. They are reducing the carbon monoxide emissions. The unburned hydrocarbon, they generally the higher or closer to the ethanol. Why means the lower boiling point, it will be easy to vaporize. That's why the hydrocarbon emission, unburned hydrocarbon emission is more on that. The oxides of nitrogen, this will be some point of view, it will be closer to that or higher value up to 20%. And smoke emission also decreases compared to the diesel. Why means up to 20% is decreases. More than 20%, it will not possible to combustion is happen. I can go for the application of the ethanol, 40% of ethanol in CI engine, modified engine operating parameter. With the help of the Taguchi and the correlation analysis, I can use the L18 array. With the L18 array, I can use the injection pressure is 170, 185, 200 bar. This is a conventional engine, not for the CRDA engine. At the 2014, I can taken all the reading, not now. It will be 2014. I can modify the engine injection timing and the compression ratio and the inlet air temperature. Based on that, I can use using the correlation analysis. I can optimize the engine operating parameter. The injection pressure is 185 bar and 27 degree. Compression ratio is 19.5 and the inlet air temperature is 100 degrees centigrade. Is the operating parameter I can fix from the Taguchi and the correlation analysis. Find out this is the best operating parameter. I can use it. I can find out up to this operating parameter E40 is better. I can changing from that E20 to E40 now. From E20 to E40, I can change the engine operating parameter up to ethanol 40% of ethanol blending with the diesel, which is a emulsifier technique with the help of the ethyl acetate and the diethyl carbonate. E40 is possible, better performance and better emission standard. The same thing I can discuss earlier. Now the E40 is better compared to the, but when you go for that higher compression ratio and the higher this operating parameter, the NOx emission is higher compared to the previous experiment. I can go for the comparative statement also. So another third method, I can go for the E50, 50% of ethanol with modified engine operating parameter. With the help of the bowl chamber, I can change. With the bowl chamber, this is a spherical bowl chamber. This one is a toroidal. So another toroidal with this squish chamber. Why I can change the bowl chamber? When you go for the any engine, there are very important how the flow rate, how the flow parameter. For example, turbulence, squish, tumble, and the swell motions. This is the air motions in the cylinder. If the swell motion is basically important in the inlet manifold, and another is called as toroidal turbulent motion is based on the piston bowl geometries. If the piston bowl geometry is, just a minute, if the piston bowl geometry is toroidal bore, it will be very faster evaporation. It will be reducing the physical delay to avoiding increasing the performance of the engine. I can go for the bowl chamber, I can change. But existing engine is, this is the spherical. I can change the bowl chamber according to this ways. So another, I can go for the thermal barrier coating. Now thermal barrier coating, I can use the three. Particularly, I am using the ethylene stabilized zirconium with aluminum oxide, molybdenum, titanium. This way I can using it. Around 300 micron I can coat it. This is what happened. Same for example, the compression ratio is again 19.5. Only the even after coating of the both piston as well as cylinder head, I can coat it. With help of that, only what happened. This thermal barrier coating, one of my students completed the PhD. Now they increasing the coating life of the system to reduce that. Okay, based on that, I can go for the better performance for the up to 50%. For example, this is the 50% of the E50 with the thermal barrier coating, modified engine operating parameter. I can calculate. It will be closer to the diesel, the better performance and the emission aspect. Fourth one, I can go for the application of the E50 and E60, E70, the ethanol in CA engine through dual fuel mode. With this same operating parameter, some of the amount of fuel I can send to the dual fuel mode with help of this operating. I can go for the E50 is the better compared to the closer to the diesel. That's why both the emission aspect as well as performance aspect as well as combustion aspect I can discuss. So another very important, up to E50 I can, and the comparison of I can. My conclusion is E50 is possible. This operating parameter, this dual fuel mode, better closer to the diesel, better performance. I can modify the engine, not for the fuel. Keep it in your mind. I can using the same fuels. After that, I can modify the fuel with help of the diethyl ether and other things. I can comparison of all the method. The brake thermal efficiency is better compared to that all the engine. The up to E50 is a better solution with help of the thermal barrier coating, other things. And the comparison of CO emission is good, and the comparison of XC emission is good. Comparison of NOx emission also reduced with help of this method. As well as the smoke emission is almost 50% diesel, you are reducing the possible. This is the following major conclusion arrived after the conducting of this engine. The first method, use the maximum 40% of ethanol unmodified engine and modify the engine, better performance. I can go for the higher percentage of ethanol CA engine, maximum engine modification. The scope of the future work, with the help of the simulation techniques and other techniques, we are using the higher compression ratio. We are using only for the 21.5. We are possible to 22, 25. The future work you should do it. It will be good performance of the engine. This is the paper I published elsewhere journal in 2014. The effect of compression ratio, performance and combustion in emission diesel engine filled ethanol diesel blend with myself and my guide Dr. G. Devarajane is a sole performer in my life. Is a good paper, almost good publication and good things happened in my 2014. And another one of my students along with me, I published 2019 the experimental investigation of thermal barrier coating in diesel engine with ethanol and other fuel also. This is the one of the paper, Ceramic International Journal. So another one of my students is effect of hydrogen fuel higher flow rate under the CRD engine with this paper is published in 2020 elsewhere journal Hydrogen Energies. So another paper is published in the effect of combustion chamber geometry. I already discussed now. This paper is published in the Thermal Science in 2014 itself. 16 I published. So another paper I can publish the ethanol paper. This one of my students dual fuel mode using the TSRB biogas using the Taylor and Francis in 2018. So another paper also, one of my students, Mr. Nevin Samuel, is using the nanoparticles. The rice husk using the nanoparticle to enhance the combustion characteristics in the biodiesel as well as in the ethanol blend. They are using it. So another student, one of the students, Mr. Murugan, is also effect of diethyl ether. I already using the igniter enhancer and the methyl ester and with the CRDA engine. What is the emission aspect and comparisons? So another myself and Mr. Jaira, one of my students, the experimental emission is thermal barrier coating. Piston used a direct injection combustion ignition engine. The thermal barriers, thermal science. So another essay I published 2020-19, the rice viscalca with the help of the fuel. These are the things up to now engine aspect. I can discuss that. These are the ethanol and alcohol fuel using the engine. Now the scenario is totally changed. Electrical vehicle. Then now the scenario is totally changed. Future aspect of the ethanol, methanol, we are with the help of the fuel cell aspect. That's why I am. That also I am. Another 5 minutes I can cover how the ethanol, methanol using the introduction on the one of my students doing the research in the fuel cell as well as HHO techniques. Mr. Dileepan, they are doing the research. Maybe another few months they will publish the paper is possible. This technique, the alcohol fuel cell. What is the fuel cell? I can give that, but after I can discuss finally this one. What is the fuel cell? The electrochemical device generate the electrical power continuously. The gaseous fuel electrochemically burned in the engine. Okay, the fuel cell is there are two things is there: anode, cathode, and the electrolyte. With the we are using the electrolyte is using the fuel. We are called as a alcohol. This electrolyte device generate the electricity required amount. Now I don't cover much more. What are the fuel cells? Is very important. The mechanical engineer, physics, and nanotechnology, and the electrical engineer, electrochemistry. These all things are involved to cover up the future generation of the alcohol vehicles. I don't discuss that much more. Why I am putting that? When you are what is the electrochemistry? You should understand. You can see that now your tongue you can getting some chemical reactions. Or you see that just once you can see the mango, immediately you can tongue you can create some electrochemistry to create some saliva in your tongue. Okay, what is the electrochemistry? To understanding between the mother and child. For example, even though you don't know mother or how you are convey the message with the help of the eye contact, the electromagnetic process. The same things, electrochemical. What is the electrochemistry? To understand these things. This is the using the lemon, how the electrochemistry happens. I don't discuss much more. Just very clever. I can, for example, fuel cell, the chemical energy converted to straight away electrical energy. The battery is the chemical energy. Here, the chemical is not a chemical energy. Storage of electrical in the chemical formation converted into the electrical energy. Here, the creation of electrical energy. Here, the storage of electrical energy. Now, the heat engine is chemical energy converted to heat energy converted to mechanical energy, then electrical energy. Okay, and so another fuel cell operation is diagram. I don't discuss much more at the time availability is very another 5 minutes is there. That's why I rush up. Only in the alcohol fuel cell, we are using the proton or polymer exchange membrane fuel cell. Not for other fuel cell, you are direct methanol fuel cell. We are using it. This is the technique. We are using the two method. We are using the alcohol fuel to use the solid oxide fuel cell. Like that, we are using it. Now the battery to fuel cell, but the battery is a very technological not available in India. Why means the lithium ion battery, the lithium is not available in India, as well as the coating technology is not available in our hand. That's why you are dependent, even you are dependent on the China or other countries. That's why But fuel cell technological is possible in future in India. Why means this is electronic method. There is no storage things required. The chemical energy converted to the electrical energy. That's why fuel cell you are using it. Okay. Okay. Here I don't discuss much more. The advantage of fuel cell: high efficiency, high fuel diversification, zero emission, and the renewable technique. Now this is the mechanical system. This is the fuel cell system. The chemical energy converted to the electrical energy. This is the process. Okay, the methanol and the ethanol. How it will be ethanol? We are using anode as well as methanol also in terms of anode. This catalyst you are forming of electrons in terms of single cell around 1.2 voltage is possible in that. Okay, this is the paper. The hybrid system. Here IC engine is there. Here fuel cell, proton exchange membrane. This proton exchange membrane to create the electric current. They are forming the electrical to get the electrical productions. This is the IC engine. That this process, both hybrid system also possible in the direct methanol fuel cell with IC engine. So another things, we are using the ethanol as a fuel with the KOH and plus water as using the electrolyte to convert the chemical energy or the production of the directly electrical energy with the help of this process. Okay, this is the scope of the future work. I can discuss the scope of the future work. Now the alcohol not using the IC engine. Instead of the IC engine, we are help of the fuel cell technology in future generation to convert the electrical vehicle is also possible in the alcohol fuel. Thank you. Hello.
Yes. Any participants, any interaction, any questions? Sir, many have posted in the chat box, sir.
Okay.
We can take one or two questions, sir.
Okay, sir. No problem.
So, emulsifier can be used for stability of the mixture. Professor Pasupati Raja, I think from Shastra, has raised a question.
Yes.
Emulsifier can be used for stability of ethanol and diesel. So, you can explain on that, sir.
The emulsifier is there. For example, the ethanol is a different composition of the chemical composition. Diesel is different chemical composition. But okay, you can this emulsifier act as a surfactant or agent to mixing. But this mixing, there are two aspects. One is called as visual aspect. You are easy to see that it will be mixing. But when you go for the microscopic aspect, some of the things of the molecule cannot be bonding with the diesel or ethanol. At that time, you have more amount of emulsifier you added. That is possible to up to the micro aspect level to emulsifier or blending is possible. Or stability is possible. Up to 6 months, I can check it. There is no separation between the ethanol and the diesel with the help of the ethyl acetate and the diethyl carbonate. Okay. You understand, sir?
Yeah, sir. I think another participant, Akash Deep Goyal, has raised the question. You have answered that. How to ensure that two are properly mixed, that ethanol and diesel are mixed. That you have now explained, sir. Very good, sir. Thank you, sir.
Okay.
What is the effect of latent heat of vaporization on combustion efficiency of biofuel? I think it's Vivek Pandey has asked this question, sir.
Okay, sir. For example, if the latent heat of vaporization is very important. For example, some accumulation of heat. For example, latent heat higher and higher, it will take the accumulation of energy suddenly burning. This happens. For example, the latent heat is vaporization lower. What happens? It will be continuously burning is possible. Start of physical and chemical delay is reduced. If the latent heat of vaporization is higher and higher, the delay is higher. That's why accumulation of heat is longer. That's why it will be sudden blasting is happening. That's why the heat release rate is higher for the alcohol fuel due to the sudden release of the burning or the pre-mixed combustion rate is higher.
Yeah,
If
yeah.
the latent heat is lower, the premixed combustion rate is lower. That's why the diesel engine, the lower small amount of premixed combustion, longer for the diffusion combustion. But in the ethanol, the premixed combustion is higher, diffusion combustion is lower due to the latent heat of appreciations.
Okay, sir. In a related question, sir,
Okay.
Sai Pavan has posted
Okay.
increasing the latent heat rate, heat release rate
Okay.
is an advantage or disadvantage from emission point of view. Heat release
The,
rate, if you
the,
increase,
the combustion point of rate will be good. Particularly the emission point of rate, I tell you, the smoke emission formation is mainly due to the absence of oxygen. That is called as pyrolysis effect. The high temperature, the absence of oxygen, what happened? This smoke formation is possible. Higher heat release rate. The sudden premixed combustion is higher. What happened? The smoke formation is higher. That's why the emission aspect will be not good.
okay, okay. So how far we are from using ethanol in our fuel in real time? David
Yes,
ethanol. Yeah.
the real
I think you
time.
have given the present status, sir. You have
Yes,
given the present status.
given the
So we will
presentation.
skip that. We will skip that, sir. Next one
Okay.
is, please explain what are the effects of change in geometry of. You have discussed the geometry
Yes,
of.
yes, yes, yes.
So,
The,
what are the effect of change in geometry of torture during combustion?
for example, the geometry is very play role is the turbulence and swirl motions and squish motion. There are 5 motion in the engine. One is called as tumble motion, squish motion, swirl motion, turbulence motion.
Yeah,
Particularly in the chain.
altogether to change the combustion
No.
phenomena.
Yeah, altogether they change the combustion. If you
Yeah.
the piston geometry you can change, you can
Okay.
increase the turbulence, increase the swirl motions.
Yeah,
This
yeah.
two aspect is enhanced. Due to this enhancement, you are reducing the physical delay, increasing the combustion duration. That's why when you are using the ethanol as a fuel, the longer ignition delay, to avoid that, with the help of the you are shorten the ignition delay with the help of these combustion geometries.
Okay. Thank you, sir. I think we have already crossed the schedule. Participants
Yes,
are posting many questions. Anyway, I think we have addressed some few questions. It will be very
okay.
good for the participants who could
Uh,
not get connected by this in a net problem. So anyway, sir, I thank our speaker of the session, Dr. V. Jnanamurthy, for presenting a very good review of the literature to highlight the current status and future direction of ethanol-based fuels for IC engine application. And he has also listed and clearly given some directions for the future research work. The highlight is the threshold limit of blending proportions. So up to 30, you need not require any modification. After that, what sort of modification you can go? So that is very interesting, sir. The threshold limit of blending proportion for which we require engine modification, and also whether we should go for fuel property modification or engine properties, how to decide that. You have also given some directions on that. So very useful session, sir. On
really,
this occasion, I thank sir for your wonderful presentation.
thank you, sir. Thank you.
Thank
Further, any queries, any research guidance, please you can contact
Okay.
my email ID.
Definitely.
Thank you, sir. Thank you
Thank
given
you,
this opportunity for Big Campus Dean as well as our campus Dean and coordinator of this program, as well as my friend Magadevan and other who are all involved in this program successfully conducting. Really, thank you, sir. Thank you for opportunity to share my view in the research in the field of alcohol fuel. Thank
Okay,
you,
sir.
Thank you, the
Thanks.
participant to involve this session. Thank you, one and all.
Thank you, sir. Thank you, sir. Dear participants, let us now break for the lunch, and we'll resume back. We will resume at 2:15 p.m. And the next session will be on the engine modifications again for IC for use of alternate fuel in IC engine. So, what sort of engine modification? How to optimize that? So that will be the next topic by Professor M. Pandian. Okay, so let us now break for lunch and meet by 2:15. Thank you for joining.